Everyone, please turn off your microphones during the session. A warm welcome is half the hospitality. As we stand at the threshold of a promising future, let us join hands in welcoming the opportunities and challenges that await us with open arms. God speaks in the silence of heart, and listening is the beginning of prayer. Let us lift our hearts in prayer through the soothing melodies of a song that connects us to the divine. I now call upon Mrs. Aishwarya to lead us into prayer.
கணந்தோறும் தன்னை கை கூப்பி வருவாரே கவனித்து துணை தருவான் கணநாதன் கணந்தோறும் தன்னை கை கூப்பி வருவாரே கவனித்து துணை தருவான் கணநாதன் நம்பிக்கை வைத்தவர்கள் நாளும் வளர்ந்திருக்க தும்பிக்கையானே துணையிருப்பான் நம்பிக்கை வைத்தவர்கள் நாளும் வளர்ந்திருக்க தும்பிக்கையானே துணையிருப்பான்.
Dr. P. Karthikeyan earned his PhD in management from Bharathiar University in 2009 and qualified with SCT in 2006. He currently serves as an associate professor in the Department of Management Studies at Congo Engineering College. Dr. Karthikeyan boasts a remarkable 21 years of work experience throughout his career. He has successfully supervised 16 PhD and 18 MPhil research scholars. Additionally, he has authored and edited 13 books in the field of management. Dr. Karthikeyan's contributions extend to participating and presenting over 100 papers at various national and international seminars, conferences, and symposia. He has also delivered more than 110 guest lectures at various colleges and universities. Moreover, he has served as a resource person and chaired sessions in more than 150 national and international conferences, workshops, and faculty development programs. He is an esteemed editorial board member and reviewer for 40 international and national journals. Dr. Karthikeyan's expertise has led to his selection as a visiting professor in the Faculty of Economics and Universities Yogyakarta, Indonesia, and at Globe College, Kathmandu, Nepal. He is also recognized by SEBI as a certified resource person for conducting financial education workshops and as a recognized assessment officer for conducting National Skill Development Corporation NSDC examinations. Dr. Karthikeyan is an alumnus of the Indian Institute of Management IIM Indore, where he completed the FDPM course over a span of 4 months. He has been honored with the Accredited Management Teacher certification from AIMA, New Delhi. His academic and research work has taken him to various countries, including Thailand, Sri Lanka, Malaysia, Singapore, Nepal, and Indonesia. It's our pleasure to invite Dr. Karthikeyan to conduct today's session. We welcome you, sir.
Thank you, Ma. Thank you very much for your nice introduction. It is my immense pleasure to welcome you all once again for the national level workshop in the topic of basic time series analysis in EViews. Myself, Professor Karthikeyan, working as a associate professor in Department of Management Studies, Congo Engineering College, Erode, Tamil Nadu. And we are conducting a lot of workshops for the betterment of the researchers and also faculty members. And we have conducted so many workshops for offline as well as online, right? And mainly it is focused on research, how to write research paper, how to obtain research funding, and related to SPSS, AMOS, and so many softwares. And it is our 4th or 5th program in the series of EViews workshop. Before Corona, we have usually conducted a lot of workshop in the area of time series and EViews. And due to the short time, we have decided to conduct the workshop in online mode. That's why we are handled the session on online today. I take this opportunity to welcome you all for this workshop. I have already informed you how to install the eView software. I have sent the information in the WhatsApp group, as well as I have shared the dataset profile in the Google Drive, so that you can able to download the dataset and we can ready for making a presentation. But however, maybe 1 hour or half an hour to 1 hour, we are going to see about the basic things in the time series analysis, e-views analysis, and econometrics analysis. First, we can see about what is time series, what is econometrics, and what is e-views. Then we slightly move on to the different practical sessions in the e-views, how you can operate it. In the meantime, I request all the participants, if possible, you can watch the session using your laptop or PC, so that it may be more vibrant for learning on eView software. You can easily install. I think I have already shared the installation procedures. You can easily give the request in the eViews page, so that you will receive the clear information in your email on software as well as the serial number. It is a 1 month free version of the student, and using the student free version, you can able to use the eView software for the period of 1 month. This is a procedure. Yes, I have already informed that I am not going to give any serial number, madam. It is all you may give the request in the eViews page, eViews download page, and the eViews company will give the or will send the serial number and all other information to your mail ID. I will give the other software, maybe the old version of the software after end of the program. Actually, it is 12th version. That's what 1 month free trial will be given to you, right? So thank you. I'm just sharing my screen. If you have any doubt in between, please always welcome. No issue, no hesitation. I will go a little bit very slow. Don't worry about, right? Please interact with me whenever it is possible. Is my screen is visible to you all? Dear participants.
Yes, sir. It is visible.
Thank you. Okay. Well, so today we will start with the introduction on time series analysis. Then I'll tell you what is time series analysis, what are all the different tests of the time series analysis. One second. Yeah. What is normality test, what is stationarity and non-stationarity, tests of stationarity, unit root, ADF, ARIMA, and everything we are going to discuss one by one. Right. So a time series means it is a sequence of numerical data in which each item is associated with a particular instant in time. So time series is a sequence of numerical data. My dear friends, please note out. And one can quote numerous example. One can quote numerous example: monthly unemployment, weekly measures of money supply, daily closing price of stock indices, and so on. So you may ask one query where we can download all this information, because any researcher who is attempted to use the secondary data collections, maybe the people using quantitative data by using secondary data, secondary data we all know. So those data which are already available in some of the resources. So in case those type of research, we can apply time series analysis. Those type of researcher can apply time series analysis. In fact, with the current progress in computer technology, we have daily series on interest rates, hourly interest rate index, stock prices based on the minute or even second. So all can be used the time series approaches. And we all know that so many researchers are only using financial analysis, financial performance, working capital management, ratio analysis, and so many research. So these are all outdated. See, econometric is a subject, it is a combination of finance, statistics, and economics. Once again, I am telling, econometrics is a subject, it is a combination of finance, econometrics, economics, and statistics. Four combination it would become, right? So an analysis of a single sequence of data is called as a univariate data. Okay, analysis of a single data is called as a univariate data. Analysis of a single data is called as a univariate data, right? Single data, single sequence. An analysis of several data, analysis of several data, okay, analysis of several data for the same sequence is called as a multivariate time series. But today, because this session is purely based on the basic time series analysis, we mainly focus on the univariate time series analysis. In future, we may conduct the different workshop in the multivariate time series also. Okay, and for a long time there has been very little communication between econometrics and time series analysts. Econometricians have emphasized economic theory and a study of contemporaneous relationship. Lagged variables were introduced but not in a systematic way. So that's why we called it as a no serious attempts were be made for studying the structure of a particular data. So we all know that so many econometric professors. So we all know that there are some universities or some colleges, they are offering exclusively econometrics courses, BA econometrics, right? So they are mainly using on economic theory to study the different relationship with each other, right? So, which means I am telling you, my dear friends, univariate means right. Univariate means it is contains only on univariate means contains on only one variable, and multivariates contains many variable. So time series model is also called as univariate model. Time series model is otherwise called as a univariate model. So the main purpose of the time series model is predict the given single variable using its own past values and possible current and past value of the error. That means y t minus 1 and y t minus 2, etc., on error term. Time series model is a theoretical and empirical in nature. Two important steps in time series model. First one, we want to obtain the internal structure of the data, and we must analyze whether this particular model is fit for forecast or other purposes. And very important, my dear colleagues, so time series data may have one or more of the following pattern. One is a trend, seasonal effect, cyclical variation, and irregular or random component. And based on that, we can use appropriate modeling for the pattern and other purpose. So we want to know about what is normality test. What is normality test? Just a second. Okay. So in the normality, we want to check the normality of the data. First, we want to check the normality. It is very easy. I don't know. I have already shared the material. Once again, I will tell you. Maybe in later I will tell you. But however, I will tell you how we can use the normality. Okay, how we can use the normality. I will use the eviews file, right? I will use any eviews file. There is a some eviews file here. I will use, don't worry, my dear researchers and academician. I will guide you how to open and all. But meantime, I will try to how I can use this data. Okay. Now I am using that. See, here we have entered the data. So now we can see here, this is the data. This is the data, right? This is the data. We go view descriptive statistics, and there is a one method called histogram where we can able to see this is the normality. Very within fraction of time we can able to see the normality of the data. So the mean value, this is actually Toronto Stock Exchange index value, right? Toronto Stock Exchange index value. So there are the observation are around 1255 days figures are shown here, and mean value, median value, maximum, minimum, standard deviation, skewness, kurtosis, and Jarkupera test and probability. Everything will be able to see here. The simple thing. I once again I will explain you very easier. See, I suppose let me try about maybe I have shared the material on workshop material. You can access the data. You can access the data in Google Drive. Hope you everybody have download the data set. Everybody has downloaded. Excuse me, I will give the time to you. Ma'am, are you, sir? Everybody is following.
Yes, sir. We downloaded it, sir.
Yes, sir. Yes, sir. Please, I will give the time. Actually, this is a basic test. Basic test. Hope everybody has downloaded the data set and eView software.
Yes, sir.
Okay, thank you. And yeah. Sir, please, ma'am, I have already informed that please download the eView software and data set. You may give some wrong email ID. That's what we have. I think the eViews company has not given the serial number. Ma'am Anaha madam is telling that. Okay. Now, okay. Thank you. Thank you all. Now, what I am trying to say, you can open a eView software. Okay, I hope you have everybody has created a shortcut in Windows so that you can able to create a eView software. Hope everybody is following.
Yes, sir.
Yes, sir.
You can open a eView software. Directly click the shortcut window.
Yes, sir.
Yeah, yes, ma'am. Thank you, thank you. Please open a eView software and click. I request you, everybody, please save your material, save the data set in your desktop or some other platform in local drive. You can copy it from the Google Drive to local drive, please. And click the file called open a foreign file. Open a foreign file. You may create a new file. You can also create an existing eViews file. Or suppose you can export the data from Excel. You click open a foreign file. Open a foreign file. And where they will ask about where you have saved the data. See, I told you I have given the material. You just to open data file. You just to open a data file you just open a data file, then click ARIMA. So there are so many data sets are available, but however, meantime, we will see about the ARIMA data set, which can be used for ARIMA calculation. You just click ARIMA. Can you able to, after double click the ARIMA, you will get this type of window. Yes, everybody has got. Can you able to follow, all of you, please? I will go a little bit slow. Don't worry about. You can
Yes, sir.
yeah, you can meantime no doubt, because it
Sir,
will.
excuse me,
Yes,
sir. Which
yeah.
file will open? Workshop material?
Arima.
Okay, sir.
Arima. Ma'am, don't worry about that, because it is our duty to give all the material to you all. I will try, because we want to cover so many topics. So maybe some of them are, I know that in online, some of them are using mobile phone. It is not possible always to listen and simultaneously work in the laptop. I understand the troubles, but anyway, I will give some time. Don't worry about. Next, you click next, again next, again next, then click the finish, then click finish. And the link imported series and alpha objects to external source, you click yes. If you click yes, this data will be displayed here. See, rice data will be there in Excel format, TFG data will be there. These are all the data, right? Wheat data will be there, right? Suppose, I will tell you, my dear friends, again, actually, you can see that this is the Excel data. This is the Excel data. I'm sorry. This is the Excel data. For this Excel data, it is actually here wheat price, rice price, TFG price. TFG means total food grains. Total food grains. Rice million tons, total food grains million tons, wheat million tons. Data as given. So this is the data we have exported in the eView software. And you just click wheat. You just double click the wheat and go to view. There is a one column called descriptive statistics. There is a one column here, descriptive statistics. View, descriptive statistics, histogram and stat. Just if you click histogram and chat, it will be displayed here. Can everybody has got this chart?
Yes, sir.
Yes, sir.
Yes, sir.
Some may be trouble. Don't worry about. I will give the record versions. Everything I will give it to you. You later on you can work out using the data set. So here, this is the wheat price. This is a normality test, descriptive statistics. So maybe you are all familiar about using in SPSS or in other software, but it is another important things you can know from this eView software. Little bit excited to make a presentation is very effectively using this software. So mean value is given, mean wheat production of mean, average, median, maximum, minimum, standard deviation, skewness, kurtosis, everything. How to interpret this? How to interpret these descriptive statistics? That's what I explained here. Skewness, mean, median, mode, everybody has known about. Zarkupera probability, everything. And skewness is near 0, kurtosis is near 3, so it is normal. So if probability is less than 0.05, we may reject HO.
Yes, sir, sorry to interrupt. Can you repeat once again the UU operations?
Okay, sir. Actually, I'm sorry. Actually, I will tell you once again. Don't worry.
Okay.
But it will take much time, sir. Once again, don't worry about. I will tell you. Okay. Please try to follow as usual, because we have so many softwares. I mean, so many tools. Can you open this one, sir?
Yes, sir. Yes, sir.
Okay. You just double click with. I'm sorry. I will close it. You open here, view descriptive statistics histogram.
Okay, sir.
View descriptive statistics histogram.
Okay, okay. Thank you.
Okay, hope you may receive right. Okay. If you want again, I am telling you, don't worry about. Okay, I'll go as a file, open foreign data as a work file, foreign data as a work file. Then I will choose the file, time series, data file arima, then click next, 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 finish. You just click yes, then the data will come, wheat. I open a data on wheat, then go to view. I will click descriptive statistics, then click histogram, and the descriptive statistics will be displayed here. Is it fine, sir? Now?
Yes, sir. Yes, sir. Yes, sir.
Okay.
Thank you.
So yeah, this is a interpretation. Skewness is near 0, kurtosis is near to 3, normal. Probability is less than 0.05, then it may be good. That is HO is reject. Okay. And yeah. So this is a normality test. Jarkupera test is also one important test. That's what we have discussed here. Probability, Jarkupera value and probability. And this is a requirements, normality requirements. Okay, requirement for parametric analysis. Okay, there are so many normality tests will be there. So see here, plus or minus speed to right or minus skewness is to be 0, and kurtosis should be approximately 3, or Jarkupera value is approximately 3. So in our test it shows about it's around 3. If at all Jarkupera value is around 3, then it is a normal. The data is a normal, and probability value is not less than, it is higher than 0.05. So HO will be accept. HO will be accept. I told you less than 0.05, less than 0.05, it is HO is reject. If higher than the 0.05, then HO will be accept. So I will share this material, this PPT at later, right? I have not shared this PPT in the presentation, I mean in the data set. This PPT, I will share it at the end of the workshop. Don't worry about. So this is likely to be normal, right? This is likely to be normal. This data, if you take example, this software, it is not a normality. So how it may be normal? See, if we draw the diagram, it's not possible. If you draw the diagram, put like, okay, then it is a normal, right? If you check this data, can you able to draw the bell shape, then it is a normal, right? We can't do like in the bell shape here. Okay, if it is bell shape means it is a likely to be normal. Hope you may see that all the center point is connected. All the center point is connected. I'm sorry, sir. I hope you have received that. This is a normal. This is the normal. See, this is a normal, right? This is a normal. We can't do the diagram on here, right? It is not a normal. See, similarly, here also it is not normal. Yes, we have arrived this data, right? We have from the eView software, we have arrived this data. It is not a normal. So that's what we have rejected that hypothesis. I mean, accept the hypothesis. There is what is HO? There is no significant difference between the wheat data. There is no significant difference between the wheat data. But what from the probability analysis, we came to know that probability is higher than the 0.05. Probability is higher than the 0.05. That one, there is no significant. We want to accept the HO. We want to accept the HO, right? So here, okay. So there is a significant difference. And yeah, next one is a stationarity. Next one is a stationarity test. Stationarity test. Okay, 1 second. Okay. So hope my screen is visible, sir.
Yes, sir.
Okay. Okay.
Yes, sir.
Thank you. Thank you, ma'am. And this stationarity and non-stationarity we will discuss. Okay, stationarity and non-stationarity we will discuss. Before that, I will explain you what is time series data. Then we will discuss about stationarity and non-stationarity. Okay. Okay. So time series have one or more of the following 4 patterns: trend, seasonal effect, cyclical variation, irregular or random component. So X is equal to T plus S plus C plus I. And that's what I have explained here. So time series analysis consists of a set of observations, measures at specified, usually equal time interval. And it is a basic tool for forecasting. Why we are using time series analysis? It is actually a basic tool to forecasting. Industry and government must forecast future activity to make a decision and plans to meet the projected changes. See here, we normally time series is a one basic tool for forecasting. Mostly the industry and the government, they want to take a decision or project some information on future. So for that, the time series analysis is mainly using as a one forecasting tool. And the trend is defined as a long-term underlying growth movement in time series. If you take example, the stock market. Suppose I want to project the Nifty movement on the Indian Stock Exchange. So what is the relationship exist in the Nifty performance? So accurate trend spotting can only be determined if the data are available for a sufficient length time. Forecasting does not produce definite results. Forecasters can and do get things wrong, from election results and football scores to the weather, anything. So it is also possible for some type of error in result. So these are all the some examples on a time series. We can use sales data, We can use gross GNP data, share prices, exchange rate, unemployment rate, population, foreign debt, interest rates. So these are all the some examples of the data where we can use the time series analysis. So these are all the four components, as I have already told you: secular trend, seasonal variation trend, cyclical variation trend, irregular variation trend. So this is the component. You can see this diagram. Hope you may see this diagram. Hope you may see this diagram, right? And here you see here. So this trend is a irregular trend. Irregular trend. Okay, this trend is a irregular trend. Okay, and this trend, cyclical trend. See this cyclical trend, down, up, down, up. Okay, you may see this irregular, continuously it is going increasing, irregular, right? This is cyclical.
Sir, how do you decide it is irregular and cyclic?
Yeah. I will come, sir. Don't worry about it. So I will come next slide. Don't worry. I'll tell you. This is trend. This is trend and seasonal. Seasonal means, see here, one season down, another season down, another season down. I'll come, sir. Here, what is trend component? Overall persistent long-term movement. And seasonal component is a regular periodic fluctuation. So trend components mean a trend, overall persistent and long-term movement. See here, this long-term movement, right? And seasonal component is a regular periodic fluctuations, usually within a 12-month period. This is seasonal. Okay, regular periodic fluctuations, usually within a 12-month period. And the cyclical component here here it is a cyclical component, right? Repeating swings or movements over more than 1 year. If you take after Corona from 2022 to 2023 or 21-22, the stock market movement is like a cyclical movement, right? The Sensex reached around 60,000, 70,000 points, or the Nifty is reached 20,000. Again, it comes swing to 16,000, 17,000 mark. Again, it take place to 20,000 marks. Repeating swings or movements over more than 1 year. And irregular, erratic or residence fluctuation. See, we can't estimate. See, certainly something is happened in fundamental. So here, some fundamental factors, maybe some bomb loss is affected, some type of Ukraine war. You can say that something economical policies. So these are all some fundamental factors. In those fundamental factors, you cannot expect, even Corona time also, erratic or residual fluctuations will happen in the irregular time series, right? So again, for the SAR question, see, he has asked about how we can fix the trends, seasonality, etc., etc. And observation increase or decrease regularly through time, it is called as trend. Again, I'm telling you, observation, sir, please clearly note out, observations increase or decrease regularly through time is called as a seasonal trend. Okay, and seasonality trend, observations stay high, then drop off and pattern repeats, right? That is season trend. Cyclical movement may be like a business cycle, introduction, growth, maturity. See here, this is an example, right? This is an example of the cyclical trend, and this is an example of the seasonality trend. Okay, and noise is a random variation, unpredictable component. I told you already, the see, noise trend is otherwise called as a irregular trend. Okay, unpredictable component that gives time series, graphs, irregular, zigzag appearance. You see that this is the forecast. So I will tell, we will discuss at later point of time in Marima chart. objectives in the forecast, how we can see. So this is an observation value, and this is an observation value. This is a forecast value. This is a forecast value. Yeah. Stationary means very important in time series analysis. We should know what is stationary, stationary and non-stationary. Okay, stationary and non-stationary. There are two words you always keep in your mind. So stationary means no trend. Okay, stationary means no trend. My dear friends, in econometrics model, in E-views, first we should convert the all data into stationary form. Please listen, all of you. Once again, I am repeating. First, the researcher should convert all the data set in the stationary. Then only we can able to apply in all tests. So that's why we have unit root test and so many tests are available that we will discuss it. So if pattern on, if no trend, right, we cannot see in this graph, there is no trend exist here. It is a stationary data. So this one is a trend. We see here it is a trend. Increases or decreases over time. Increases and decreases over a time. This is a trend. It is not a stationarity data. It is not a stationarity data. Okay. This is cyclical trend. See, pattern 2 is a trend. Pattern 1 is a stationary. Pattern 2 is a trend. Pattern 3 is a seasonality variation trend. See here seasonality variation. Residual consumption, industrial consumption, commercial consumption. This is a 3-month treasury bill rate. It is a cyclical trend. Sometime it up, down, etc. Right? That's what I told you. Box-Jenkins method. According to Box-Jenkins method, all the time series should be stationary. All the time series data should be stationary. Very, very important. Okay. According to Box and Jenkins method, all the time series should be stationary. So any stationary times series can be self predicts its own future from the past data. Right. Now I'll tell you we know that not all time series are stationary. However, it is easy to convert a trend or a seasonal time series to a stationary time series simply using the concept called differencing, lag differencing. Simply using the concept of differencing. Example of differencing is nothing but this is t data. This is y minus t, right? Then yt minus yt minus 1. Okay, yt minus 1. So this is a data 89, 90, etc. etc. So this is a yt. This is a time period. Okay, this is a time period. This is a time period 86, this 1986, 1987, 1988, 1989, 1990. If you take example, this is some data, sales data, 90, 92, 93, 98, 100. Assume that. So we can use this data if sometime the say example here 92, again it may be like 85, right? Again it may be 80. Okay, assume that this may be 100. If you use this data, it is not a trend, right? It is not stationary. No stationary. We can't find it is a no stationary. So what we will use, we use the difference between these data. So first thing, no, 92, 92, it is a 2, and 92, 85, it is a 7, then again 5, then 20. If we use this difference data, then it becomes stationary. So simple logic, right? I will explain you, don't worry about. I will explain during our calculation. Convert a trend time series. This is the example, this one is the actual data. And if using the difference data, this diagram, right? Difference value. So convert seasonal time series to the stationary time series. It is very important for making all time series into stationary time series. Okay, I'll come to the next one. Yes, yeah, correct. Secular trend. What is secular? Again, I am telling you, secular trend is a long term, right? Mean of 10 years. This is an example of secular trend. This is an example of secular trend. Seasonal variations. Examples: air conditioner sales in summer, heater sales in winter, flu cases in winter, airline tickets for flights during school vacations. These are seasonal variations. Okay, this is an example of the seasonal variation. If you take in air conditioner sales in summer is very high, during winter it may be very low, right? And seasonal movement. We example, right? That's what I told you, right? Seasonal movement. Periodic fluctuations. Cracker sales would be very high during Deepavali time, and other time the sales are very less. Okay. And cyclical variations, recurring patterns, erratic time scales. This may include like floods, wars, changes in interest rate, economic depressions and recessions, changes in consumer spending, etc. Okay, this may be expansion period. This is a peak period. If you take example, I'll tell you. So this may be because of government policy. So this is an introduction stage, and the government stability, the government policy, it may be increased and reached peak level, and this means fundamental interest rate changes make the government. That's why the stock market will comes down. Again, it made something favorable to the industry. Then again, it pick up. So actual growth. So GDP projected growth, etc., like that, right? So this is cyclical variations. Irregular variations, you may not get no pattern, particularly in the stock market on daily fluctuations. So daily fluctuations are irregular pattern. Okay, irregular pattern. So sudden changes in interest rate, collapse of companies, natural disasters. If you take something is happen, if you take come to the Adani case, right? Adani, the Hindenburg has told some report, and immediately it reflect in the stock prices of Adani. Simultaneously, many examples of the coffee day company, when the coffee day owner Siddhartha has committed suicide, and the company policies has changed. That's why the share prices of the coffee day has gone down. Then if you take example Satyam Computers case, so before 10-15 years back I am talking about. Similarly, it is all irregular variation pattern, right? Sudden shifts in government policy. Sometimes the government is not favorable to the FDI, FII, then automatically it reflect in the stock exchange, right? It is all irregular variation in the stock prices movement. So population changes, productivity improvement, technological changes, market changes. Okay. So far, dear colleagues, so far, sir, any doubt so far? Any doubt so far?
Sir, why did we do normality test, sir?
Yes, sir. I will tell you. I will tell you during our practical sessions. Normality test means we want to check whether our data is normal or not. Like I draw in the bell shape, no? So data should be normally distributed. Then only we can take this data to further analysis. That's why we are doing normality analysis. Not only that, we can check that descriptive analysis. What is the mean of the data, median, mode, standard deviation, etc. That's why we are doing normality tests. So many tests are available, but normality is here in my yes, sorry, in EViews it is a thing we are doing normality tests.
Sir, but if it is except for a trend, any
Hmm.
seasonal or
Hmm.
variations,
Hmm.
the data will not be normal also because
Correct. That's why we are doing a differencing model. We are using logarithm data. I will tell you, sir. I will tell you during our session. I will tell you.
thank you, sir.
Sir, I have a similar question with respect to
Hmm.
stationarity. Why do we need to check the stationarity of the data?
Ma'am,
Why do we need to check the stationarity of the data, sir?
because if we are not made any stationarity, we cannot use the stationarity for the further analysis. That's why we are making the data into stationary. Okay.
Okay.
I hope I will explain you at a later point of my presentation. Why we need a stationarity means mainly the stationarity is need the data should be make it in the further analysis. To make it in the further analysis, that's why we are doing stationarity test.
Oh, okay. Thank you, sir. Thank you.
Any more question? In the time series, you all know that if you take a stationarity, the model will not be able to faithfully when it will reflect on underlying patterns. So the data, if at all non-stationary, we cannot use that non-stationary data for findings and other purposes because the findings will be erroneous. So that's why the non-stationarity result will lead incorrect or misleading in another data, or in justification is also take place wrongly. That's why we want to use only the stationarity. I mean, we want to use that stationary before making any analysis. So that is the main purpose. Stationarity is a test. It is an important test or important concept for a time series analysis for mainly how the data is perceived and predicted. Mainly in the case of forecasting, I told you time series is mainly for forecasting. When forecasting or predicting the future, most time series models assume that each point is independent of one another. That's why the stationarity is required, ma'am. Okay? Yeah.
Sir,
Uh,
other than that, if we don't
yeah.
find our data normal or stationary, so is there any possibility to make the data stationary or normal? It-
Sir, I can't understand. Once again.
uh
Sir, 1 second, sir. Please tell me the question.
Okay, the question is that if our data is not normal or
Okay.
stationary, in
Okay.
that case, according to you, your interpretation, we cannot proceed for further analysis,
So
right?
we can convert our data into stationary. That
Okay.
is the procedure. It is available in the EView software. We can
Uh-huh.
convert the non-stationarity data into stationarity. Then we
Uh-huh.
can apply for further analysis.
So it will be a biased, or it's a normal thing in research to do, right?
In the normal thing in the research can be do.
Okay, so it is justified. So we need to give the justification why we have stationary data, right?
Correct, exactly. Because when we
Okay.
go to learn very deep on time series and econometric models, the mathematician, statistician are all using the terminologies of equations. So this is a stationarity. When the stationarity means this is an equation, then it is a non-stationarity means this is a equation. Like that, we are using the similar data, right? So many things are there, but maybe this session is only on basic understanding on time series. We cannot go for deep understanding on all these concepts, but it is wide. That's what I told you. We are seeing only univariate today, right? And only few analyses, right, sir? But
Okay.
if you want to clearly learn on time series, it is like an ocean. So many things we want to learn. Even there is one more software called Gretel. Okay? Along with this e-views, there is one more software called Gretel. There is one more software called Stata. So many softwares are there. Each have merits, each have also demerits. Okay, sir. Thank you. Thank
Okay.
you for your wonderful question.
Thank you, sir.
Okay, I will go with. Okay. This is econometrics. This is an econometrics. So econometric is, sir, can you able to see my screen?
Yes, sir.
Yes,
Okay,
sir.
thank you. Okay. So now
Yes, sir.
a little bit, I just move to the time. I gave some intro about time series. Then I will start with the intro on econometrics. Econometrics. So econometry is an economic measurement. It is an application of the mathematical statistics to economic data in order to lend empirical support to the economic mathematical models and obtain numerical results. Okay. And coming to the definition number 3, it is a quantitative analysis of actual phenomena based on concurrent development of theory and observation related by appropriate methods of inferences. Then there is one more econometric definition according to the social science, which applies, that's what I already told you, economics, mathematics, and statistical inference to the analysis of economic phenomena. It is a empirical determination of economic law. Econometrics is a empirical determination of economic law. And it is a conjunction of economic theory and actual measurements using the theory and the technique of statistical inference as a bridge pair. So coming to that, I have already told you, econometrics is a combination of economics, mathematics and statistics, and I'll tell you finance also, mathematical economics and economic theory. So here I have rated economic statistics, mathematical economics, and economic theory. So using econometrics, we can do any further definition on these 4 aspects. Why, you may ask a question, why it is a separate discipline? Economic theory makes statements that are mostly qualitative in nature, while econometrics give empirical content to most economic theory. And mathematical economics is to express economic theory in mathematical form without empirical verifications of the theory, while econometric is mainly interested in the latter. And coming to the economic statistics, we know that economic statistics is a collection, processing, and presenting of the economic data. But come to mathematical statistics, it provides many tools on economic analysis. Okay, it provides many tools for economic analysis or economic studies. So how to define the methodology on econometrics? First, we want to theory, a statement of the theory or hypothesis. Then we want to specific the mathematical model, y is equal to a plus, same model, right? First, we want to provide the what is the theory or hypothesis. Then we want to specify the mathematical model. Then we want to specify the econometric model and the theory. Then we want to obtain the data, right? We want to obtain the data. Then we want to go for estimating the econometric model. Then go to hypothesis testing or giving the result and interpretation. Then we are going to forecast our prediction, and we are going to using the model for control or policy measures, right? This is the slide I told you already. This is an anatomy of economic modeling, econometric modeling. First one, we want to build a economic theory. So here one is, first step is we want to go for economic theory. Consumption increases as income increases. So, but not as much as the increase in income. This is a theory or hypothesis. Based on the theory or hypothesis, we want to specify the mathematical model, right? Y is equal to beta 1, beta 2x, right? Y means consumption of expenditure, x means income, beta 1, beta 2 are parameters, beta 1 is an intercept, and beta 2 is a slope of coefficient. And based on the specification of mathematical model, we are going to do the econometric model. So y means consumption expenditure, x is an income. The same manner we want to do the, one second, I'm sorry for. Okay, I'm sorry, there is some disturbance. Okay, the third one is a specification of the theory, specification of the econometric model. Then fourth one, we want to obtain the data on expenditure and the gross domestic product, etc. Then fifth one is, after obtaining the data, we want to check what is the econometric model, estimate the econometric model, and we want to provide the hypothesis testing result, then forecast the prediction on the GDP and the consumption expenditure, and we are going to provide the result or interpretation using the model. This is a purpose or anatomy of economic modeling. So economic theory, mathematical model of theory, econometric model of theory, obtaining the data, estimation, hypothesis testing, forecasting or prediction of the data, and using the model for control all policy purposes. Okay, and yeah, similar, yeah. This is an anatomy of econometrics. So I have explained those. Similarly, I have put it in the diagram. Theory, model, mathematical model, econometric model. Then we obtain the data collection. We go for estimation, hypothesis testing. If not fulfill the hypothesis testing, again we go for data collection, forecast, then application in control or policy studies. Okay. Yeah. Now I am telling that what is stationarity, what is non-stationarity. Sir, can you able to see the slide?
Yes, sir.
Okay, okay. I will address all the question at the end of this presentation. Okay. So if you have still worry about how to install, I will once again I will tell you after the some short break, maybe after 11 o'clock. So meantime, I will tell you how to do econometrics stationarity. Okay. Stationarity and non-stationarity, right? What is stationarity? What is non-stationarity? Right? I told you this is a normal. The data series is said to be stationary, which means, right, the mean and variance are constant over time. And the value of covariance between two time periods depends only on the distance or lag between two time periods. Then it is stationary. Okay, then it is stationary. In other words, a time series is said to be stationary if its mean variance and covariance are time invariant. If the mean, variance and covariance of the data series that you have collected obtained are varying over the time, then we called it is a non-stationary data. Non-stationary data. Okay. If the collection of the data or obtain the data, mean variance covariance is not matched or varying, then it be called as a non-stationary. And very important, that's what I told you, normality also, right? The stationarity of the data is important as most time series models works only if the data is stationary. That is the answer for the question raised by, I think, the question was raised by, who has raised the question? I think Professor, yeah,
Sir, it was
Professor
me. Yes.
Surveys, yeah, ma'am, Salini ma'am also
Yes.
asked, and Sarfraz Javed sir has also asked the question, why we want to conduct the stationarity, right? If the stationarity of the data is important, yes, most time series models are works if only the data is stationary. And what is stationary and what is non-stationary? Non-stationary means there is unit root, and stationary means there is no unit root. And all econometric data need to be no unit root or stationary for further analysis. Okay, all econometric data need to be no unit root or stationary for further analysis. What is stationary time series? Right. A stationary time series is one whose statistical properties such as mean, variance, autocorrelation, etc. are all constant over time. Okay. See here, these are all examples of non-stationary time series. When you look on the, one second. Okay, so this is actually an examples of the graphs for non-stationary, examples for the graphs as a non-stationary, and these are all the examples of the graphs for stationary. Simply I will tell you, this is an example of One second. This is a non-stationary. When you plot the straight line, if it comes on match, then it is a stationary. See here, we cannot draw the center part, right? We cannot draw the center diagram. So that's why it is a non-stationary. But when you talk about this, so all are stationary. Why it is stationary? Because here, if you draw the center part, all the curves are match. All upward, downward trend are match. Hope you all understand and agree with me, right? So
Yes, sir.
that's why it is a stationary time series analysis. Okay? It is a stationary time series analysis and non-stationary time series analysis. I will, before going for further, I take you again for this data, same data on eViews, okay, on ARIMA. Hope everybody has following. Once again, I will explain you how to create ARIMA data in eViews. Go to eView software, open eView software. The recent files data will be displayed here, and you can go open a foreign data file, then for further analysis. Otherwise, you just click ARIMA. It will go next, then finish. You just click yes, then click the data on wheat, view, graph, view and graph. You see that this is the graph trend. You cannot plot the center line for this graph. So whether it is a stationary or non-stationary, sir? Can anybody?
Non-stationary.
Non-stationary, sir.
Non-stationary.
Exactly. It is a non-stationary. That's why I tell you simply, it is a non-stationary data. See here, you can go to view. There is a one test called unit root test. There is a one test called unit root test. View, unit root test. Go to standard unit root test. And there is a test method called ADF. Mainly we are using ADF, Augmented Dickey-Fuller test. This is a unit root test. Okay. Again, once again, I am explaining you. First thing I told you, just a second, right? First, open a wheat data, any data, not only wheat, I can open rice data. I can draw the diagram on graph, right? I can draw the graph on rice. So it is also non-stationary. Then what I should do again? I'll go view, there is a one important test in econometrics and time series, unit root test. Most of the research paper, it will start with the unit root test because it is a test where we can make it all non-stationary data into stationary data. Unit root test where you can make all non-stationary data into stationary data. Unit root test, standard unit root test, if you check with the first ADF and SIC criteria. Okay, SIC. AIC also there, Akachi info criterion. Then there is another method called SCI, Sigarov info criterion method. As usual, level intercept, you just click OK. Here probability value is 0.811. It is higher than 0.05. Okay, it is higher than 0.05. So we cannot use this data. So it is a we required stationary. Rice data has a unit root. So then probability is 0.811. It should be below 0.05. The probability value should be 0.05 means it is a stationary. Okay. Then what I am going to do, you go to view, again click unit root test, again go to standard unit root. In order to go for level, first you go to first difference. Again, you may find that it is an actually intercept or trend and intercept. You can click anything, not a problem, because when you see the diagram, there is a trend will be there. So you always keep on see first. You can first order level itself. You can click trend and intercept, no issue. Okay, or here standard, right, intercept. No, the first difference, when you make first difference, click means the probability will come. Probability will come 0.00. The probability will come. Now it is the data is become stationary. Now the data will become stationary. You may use for further test and forecast. So first important thing is we want to perform stationary data. I will explain one by one, even in coming our practical session also. I will explain you one by one. Okay.
Hello, sir.
Yes, sir. Yes, sir. Please.
So I have one clarification. Then when we convert the probability, is it at 1%, 5%, or at 10%, sir?
Mostly it is all 5%, sir. We can see look into the figure on 0.05.
Okay, sir. No, I just have one more additional question, sir. Like some of the papers, they mention with star mark 1%, star mark 5%. Then
that
how do we try to?
Yeah, in interpretation itself, in the result interpretation itself, if in the output part, if it are shown that, then you may put it as a strike mark or a star mark. Then you can write the results are displayed in the 1% significance level.
So
but
can you just
mostly,
go to the previous slide, sir? Yeah, sir. Here, 1%, 5%, 10%. Test critical value. Is it at this level that we are being trying to say, sir? It is probability.
No, probability means it is actually you cannot get any results here. Here 1% values, 5% is all critical value.
Okay.
We are only seeing that probability value.
Fine.
Okay, probability value. Probability value is, I mean, this probability value is less than significance value, 0.05 or 0.01 or 0.10. For any way, it is less than 0.01 or it is also less than 0.05. You need not worry about.
Okay. So like, let's say for 1% is 0.01.
See, actually, sir, that 0.05 means 5% significance level, 95% confidence level, right?
Right.
So, right. Okay. 0.01 means 1% significance level, 99% confidence level.
Right.
Okay. 0.05 we always consider. Okay. For testing the result, we always consider about 0.05.
Right. Okay. Thank you, sir.
Yeah. Coming to that, our make presentation here. These are all the stationary time series data.
Sir, one question.
Yeah, please.
Sir, we are converting the non-normal data to a normal data or to a standard data. Will that not bias my results, or aren't we forcing the data?
No, definitely it may not bias, because it is a condition on the econometric model. It is a condition of the econometric model where we always want to convert the non-stationary data into stationary data. Then only we can apply in most of the most of the tests in the further analysis in the eView software.
Okay, sir, because normally they say if the data is not normal or non-standard, we'll have to increase the population or sample.
Correct. Yeah. You are talking about in statistics. Yeah, that fine. But here, how we can include the population or sample? We are using only on secondary data, no, sir.
Okay, sir.
Right. Professor Amudan is asking the questions on what is the serial number of eViews for download. Actually, I have sent all the information in the WhatsApp, everything. See, first we want, again, once again, I'm telling you for your benefit. Yeah. You go to eView software. Okay. You just click eView software free download. There is a student version download.
Yes, sir.
Here.
It is there in the link, sir. It is there in the link. Then we have done it.
Yeah. If you
but it is asking for serial number.
Sir, wait, sir. you will require 24 character serial number. Then you click request page.
Oh.
If you click request page, you want to fill all the details here and submit request serial number. After that, you will receive the serial number and installation procedure in the email.
Oh, email.
Okay. This is the procedure for all the participants. Once again, I am explaining you. You go to search it in Google. Use 11 student version download. You just click. Then you can find there is a request page. You click request page. You fill all the details here. Then send the request serial number button, and you may receive the notification in your mail. I will show the mail also.
For the details.
Yeah, this is a mail. Hopefully, you might receive in your email. This is a procedure. This is a serial number. And while you are installing this, first you want to download the eView software. After you want to installation, first you download the software. After download the software exe file, you want to install the software. During the installation procedure, they will ask about the serial number. Kindly give the serial number of the numbers where you have received some mail. No, that serial number you have to give. Okay, and the students version will be valid for 1 month. Okay. Hope everybody got it clear.
So we can't get it for permanently, right, sir? And again, we have down.
So actually, it is a paid
if I
software.
want to use it next month.
But actually, it is not an open source software. It is a paid software. So for in one user, we have a license in our institution. I think it is around 60,000 or 70,000, 50,000 or 60,000. I'm not sure. It is for 1 year, we want to pay something. Okay. Okay.
All right, sir. Thank you.
Yeah. Okay. Juice. Huh? Okay. So the stationarity test is important in time series analysis. Empirical work based on time series data, it assumes that underlying time series is stationary. Non-stationarity time series data is one among the several causes of autocorrelation. And regressing non-stationary time series is variable on another time series may lead to spurious regression. Some financial time series exhibit random walk phenomenon, changes in due to error term. If this is fact, forecasting would be futile exercise. It is not possible. Then causality test, Granger and Sims assume that the time series involved in analysis are stationary. Okay. And if the time series is non-stationary, we can study its behavior only for the time period under consideration. And as a consequence, we cannot generalize it to other time periods. Therefore, forecasting of non-stationary time series may be little practical value. I hope I have given clearly all information with persist to your all questions. Okay. These are all the different tests we can check the stationarity, right? We can check the stationarity. First one is a graphical analysis. This is a graphical analysis, right? This is a graphical analysis. As I told you, in the eViews, you can open any data, not an issue. I have given the data set. You can open any data as you wish, don't worry. I will use some data, Excel data. Okay. I make it here. See, this is the Toronto Stock Exchange data. First analysis for stationary is a graphical view, right? And I will check here, view graph and line graph. You click here whether this data is a stationary or not, right? If this type of diagram is a stationary diagram, this is non-stationary diagram, non-stationary graph. Hope when you check here, you cannot get exact on it is not a stationary. Even you can check with the unit root, standard unit root. It is not a stationary. It is not a stationary data. Okay. In the graph also, you may see that it is not a stationary. Similarly here also, right? Then you can also check with the auto correlation function, Carlogram. How to calculate a Carlogram? Again, you can go to view. See, everybody, please, I will tell you. Open any data set. First one, you can view graph is the first procedure to check the stationarity. Here it is not stationarity. Then again, view Carlogram. You can click with the as usual level, click OK. Again, it is Carlogram. One spike in PC, partial correlation, and the auto correlation, so many spike. Again, you can check here the similar. If it is a stationary, means no spike at all. So we came to know that in the Carlogram result in this data, it is non-stationary. It is non-stationary. In the Carlogram result also, it is non-stationary. Then come to, third test is a unit root. Third test is a unit root analysis. I have already explained you, but anyway, we will check it. Okay. So unit root test. So first one, graphical analysis, then Carlogram, and these are all the different methods. 3 to 7s are all three different methods of unit root. This is one way we can check. This is another way we can check. And these are all the different tests of unit root analysis. The first important test is an ADF test. ADF is a very important. Among all the tests, ADF is an important test. Accumulated Dickey-Fuller test. Some of the researchers, they also go Phillips-Perron test. Okay. So unit root test is test whether a time series variable is non-stationary and possesses a unit root. The null hypothesis is generally defined as the presence of unit root, and alternative hypothesis is either stationarity, trend stationarity, or explosive root depending on the test. If a non-time series, a YT has to be differential. Okay, if time non-stationary is coming, then I told you already, we must go for differential result. We must go for differential result of D times to make it as stationary. To make it as stationary. Then YT is said to be contain unit root. It is customary, it denotes YT minus difference. D is a difference value, difference, right? D is a difference. That's what it is integrated as. YT is integrated of order D. Okay. These are all the different tests of stationarity in the Dickey-Fuller test, Agumanda-Dickey-Fuller test, Blips-Paran test, Dickey-Pandula unit root test, GLS, ERS, KPSS, Indian Paran, so many types of unit root test, right? These are all the sum formulas. So due to the time constraints, I'm not going to discuss much on what is it. I will share this PPT to you. Whenever we are using the ADF test or any test, we should, when we write at the time of writing a research paper, we should quote this equation. We should quote this equation or at the time of writing a thesis or any research paper when we using ADF test. Any test, Phillips Paran, KPS, etc., right? Only one thing I just want to tell you, very important. See here, most of the test, a null hypothesis is a unit root. Okay, in the unit root test, mostly a null hypothesis is a variable has unit root. It is applicable to ADF, Dickey-Fuller, and all the tests. And the reversed hypothesis can be observed in case of only KPS. Okay, in case of KPS, it is a reversed hypothesis, which means null hypothesis, right? Once again, for a KPS test, just a second, one urgent call.
சொல்லுங்க மேடம். ஏன் மேடம் அவங்க ஆட் பண்ண மாட்டாங்களா? ஒரு வாட்டி இல்லை மேடம், ஏன்னா ஒரு வாட்டிக்கும் நம்ம கரெக்ட் பண்ண தப்பாயிடுச்சுன்னா பிரச்சனை ஆகிடும். அதனால தான் பார்க்குறேன்.
Okay, thank you. Yeah.
Sir, நான் பார்த்துருக்கேன்.
Sir, actually the participants, some participants, please. Sir, Venkatesan sir, please mute yourself, sir, please. Venkatesan sir. Thank you. Okay. See here, I told you most of the test, the null hypothesis as variable has an unit root. For ADF, okay, for the ADF, here, ADF, Dickey-Fuller, GLF, and etc. But KPS alone, it is just a reversed hypothesis. Reversed hypothesis means when we use the KPS test, here null hypothesis, a variable has a unit root, and alternative hypothesis, a variable has unit root. I'm sorry, variable has no unit root, right? No unit root. Here variable has a unit root. In case only KPS. And remaining thing, a variable has a unit root, a variable has no unit root in case of ADF, Dickey-Fuller, and Philip-Paran test. This is the only thing you just note out. It is the only thing it is just we want to note out. But anyway, 95%, 99% we are using only ADF test. You need not worry about. Right? Okay. We will go with the discussion further. We go view first one. I told you graph. Okay, we came to know that it is a stationary, non-stationary. Then we go parallelogram, From the parallelogram also, we know that there is a one spike over there. So we also know that it is non-stationary. Then again, we go to unit root test, standard test. Here only the test type is there. Tiki Fuller, Plipperon, so many types, right? We cannot study that this is KPSS. This is KPSS. For the KPSS test only, the reversed hypothesis will be followed. So only we are following augmented Tiki Fuller. We need not worry about augmented Tiki Fuller. The selection method SIC, don't worry about. Then we click OK. We find that the probability is 0.51. So it is not non-stationary. So what we want to see here, again you go to unit trust. If you find in the trend, then you click trend in the chart. But in the chart, we cannot find the trend. See, if you take example in the graph, so in the graph, see, the graph, one second. Sorry. If you see in the graph, right, in the graph, it is not going on trend. The movement is not trend. Okay, see, it is only flat. It is only flat. If it is trend, if you see in the graph it is a trend, then you can at the time of you are going on unit root file, you want to click trend and intercept. You cannot find is any trend in the graphs, then you click only intercept. So we check with the unit root level, intercept, click OK. Then we came to know that it is non-stationary. What again we want to do? We go view, again unit root, standard unit root test, click first difference, then click OK, then probability. The data is made as stationary one. The data is made as stationary one. Now the data is stationary. Okay. Hope you all understand. Hope you all understand. Okay, this is unit root test. This is unit root test. If you have any queries, I will solve that. We will have short break, maybe 10 to 15 minutes. Okay, 10 to 15 minutes. Then we will exactly by around 25, around 11:25, we will again we will start our discussion. So far we discussed about the introduction part on time series, introduction part on econometrics. Then I also teach you the different methods on normality test in UV views, normality. Then we check with the parallelogram, graphical analysis, then unit root test, Hope you have learned something on the software. If you have any queries further, please go ahead.
I have three small queries, sir. Can I ask?
Yes, sir. Please. Okay.
Okay. So I have three queries actually, and these are very basics. After calculating stationary data, means when we have the non-stationary, we convert it into stationary data. Now, do we have to save the data in another sheet, or it will save automatically to run further analysis?
Okay, it will automatically save, because from the window of unit root only we are going to take place in the further analysis. Okay, from the window of the unit root only we are going to go for further analysis. You need not worry about.
So it will not change our Excel file which we have uploaded?
Correct.
Or it will change?
You will not do it anything.
We will not do it. So we will have the Excel file after stationary data, right?
No, we don't have Excel file. Maybe for the next session, I will teach you how we can use the data set and etc. At the time, you can learn better understanding.
My second question, what form of the data eViews accepted? For example, sometimes we have quarterly data available. Sometimes we have
any data, any form.
Any data.
The only thing is you want to make it in Excel.
Okay, so for example, if we have multiple data in a single sheet, which is some of them are quarterly, some of them are yearly. So it is possible for the EVUs to convert means automatically, or do we have to
No, no,
provide a
no. It is
similar?
there are so many things are there. Yearly data, quarterly data, e-views. There are lot of options. When we going to learn on like see univariate data, right? We are just today we are going to start only on univariate data, right? Multivariate data. When we talk about multivariate time series analysis and all, your question is correct. We want to convert as quarterly, then half yearly, then daily. There are so many things are there, right? Definitely, we want to do some changes in the EView software when we take place on these type of when we handle these type of data.
Mhm. My last question is, sir, when we are writing the model of our study, so EVUs can help in writing the model, or do we have to use Excel or another software to write it?
I
The
can't
model
understand. Actually,
relationship,
sir,
the model
now,
relationship
yeah,
alpha
once
beta.
again, yeah, once again, I'm going before going to take a third question. You told that different types of the series like quarterly and etc. When we there is a one specific the same time series analysis model E views. When we talk about the panel data we call it as a panel data
Mhm.
pool of data, right?
Yes.
Panel data at the time of doing a panel data analysis, definitely we want to convert quarterly, weekly and different types of data. That your question is absolutely correct. And what is the
Mhm.
third question, sir?
Third question regarding to write the model means the
Hmm.
relation between these variables alpha beta constant. So do we have to use EVUs or Excel?
No, actually, this you have when you want to do any research model, you need not worry about to write. See, automatically the UUs will take calculate all the necessary things. But when writing a research paper and writing in thesis, you want to write the algorithm or steps or some type of formula or equation, how you have take place and etc, right?
Yes.
In the e-views itself, there is a column called estimate equation. There is a steps it is there in quick estimate equation. In the next session probably we are going to learn how to estimate the equation and all. At the time you can learn better understanding on how
Thank
we
you, sir. I
e-views.
got it. I get it. Thank you, sir.
Hello, sir.
Yeah, please, sir.
Sir, like I previously used a student version 12, sir.
Hmm.
But I just want to have query, like how can we transfer the image of EVS 12 into the Word, sir? Is it any possibility? Because I tried, but I could not able to get it.
So right clicks, copy it and paste it, sir. Now I did know, sir. It's similarly,
Yeah.
when I use the right click, there is an, if you click output, right click, you may find that there is a copy clipboard or something, right?
Okay,
Then
sir.
paste it in the Excel or Word or whatever the software you require.
Okay. Okay. Right. Thank you, sir.
Okay, we have a short break. Even I maybe 11:20 or I mean sorry, already 11:16. So we'll come by 11:25 or 30. Maximum by 30. Before 30, please assemble all.
Yes, sir.
Sir, hope everybody has joined. Shall we start?
Yes, sir.
Okay, sir.
Okay. Just a minute. I will send some information in the WhatsApp so that everybody will join. Or can somebody please also send? I think anybody can send the message. I'm not sure. Yeah, we will send. I will send it to you. Okay. Okay. Now, well, I'm just sharing screen. This where we have going to discuss on what is e-views, right? So far we learned about econometrics and also we learned about time series. Then why e-views is a software where we are going to use, right? Actually, it is an easy to use statistical software with econometric and economic modeling package. There are three ways to work in e-views. There are three ways in work in e-views, right? There are three ways in work in e-views. One is a graphical user interface using mouse and menus and dialogues. Single commands using command window. And we can also use by program files, commands assembled in a script executed in batch mode. But mostly we are all using user face interface, graphical user interface. And this is a e-views desktop, command window and object window. Okay, command window and object window. This is a main menu. You can see that path directory, database, work file, etc. You can able to see in the object window, right? So e-views does not open up with a blank generic document, right? Very important, does not open a blank generic document. E-views documents are called as work files. It's need to be created and are not generic. They will contain information about your data. E-views actually it is an object-oriented program, and it is objects or collections of information related to different types of series or a groups or an equations or some types of tables or some type of graphs. And most of the work files or holders of this is called as an objects. So these are all some type of series, groups and equations, right? And this is an work file. Okay, this first thing is work file title bar, work file toolbar. We said that is view, preview, object, save, freeze, etc. See, I will tell you in eViews itself.
Sir, your voice is breaking, sir.
Yes, sir. Can you able to hear? Can you able
Yes,
to
sir.
hear?
Yes, sir.
Yeah, thank you. While you open here, this is an eViews file. Okay, just a second. You open any file, right? I will open this file. Okay. Now you can see that similar type of file. This is a title bar, work file tool bar, work file window, and work file. So here you can check here. This is a work file name. I have not given any work file name, similar name. If you want, you can give rename work file page, anything, right? Anything is possible.
Sir, excuse me. After going to the file, now I've taken the main window. Allow.
Okay.
After just do I have to click the file, sir? If I click the file, two items are open: existing and new work
Yes, sir.
file.
Yes, sir. I will explain you, sir. Don't worry. I will explain.
Do I have to press the new work file or
that is up to you? If you want to create a new work file, you create new work file, or if you want to
it is already there now.
No, if you want to open an existing file,
okay,
then create an click existing file and get the data from the
drive.
Get the data from the any of the drive, Google Drive, I mean C drive or D column or something.
Yes, yes, you're right.
This is an e-voice work file, name of the work file and sample, how many observations are there. And these are all different objects, e-file, e-voice work file and objects. This is related to details on the e-views work files. Object window. Okay, object window. The serious object. This is for all your learning only. I will share this PPT. Group object. Okay, equation object. View, command, every object I am explaining with that. Command. Okay. And see how we can create the e-views file. So here I will go with, okay, there is a one file called data in the work file. I'll close that. First, what I should do. Yeah, now you close all the files. You just go to eView software, open eView software. There are several methods. You can go to file, open. You can close all the things. You can go to file, open, eViews work file. eViews work file. You just give any name and click open. I'm sorry, it is not open. If it is available, then it is open. Otherwise, it will not come. Right? It will not come. Open foreign data as a work file, then you can convert any, get any Excel file or file, open database. You can create any database also. Okay, you can create any database. Now, I'll tell you. So click file, new work file, right? File, new work file.
So, if I want to get data from the drive which is sent by you.
Sir, 1 second, sir. I will tell you, sir. File.
Okay.
New work file. Sir, I have not to tell you to open your data what I have sent you already. This is our common procedures, right? Follow that. Software common procedures. I have not yet started any data set operation. Don't worry about that. Right? This is a method where we are creating a eViews work file. So first way where we are going to go to create a work file, how we can create a work file. Go to file, new and work file. Okay, go to file, new work file, then frequency data. So what type of frequency data, right? Which one is monthly or annually? How you ask, Sir has also asked, somebody has asked the question, which type of frequency data, right? Suppose I'm going with the annual. Start date and end date also you can provide. Then work file name, it is an optional. If you require, then you can provide, right? This is dated. You can provide the date. If you require, you can provide the date. Then click OK. I'm sorry. Dated regular frequency. Okay, dated regular frequency. Then date specification. You must provide the date, start date and end date. Then click OK. You want to provide the start date and end date. Then click OK.
Is it compulsory, sir? Start date, end date?
Sir, there are different methods. If you want to create a new work file, it is a method. Otherwise, it is not required. See, I will tell you, see, I'm going to start 1950 to 2000, 1960 and click OK. If you click here, it is open, right? 1950 to 1960. This is residual data. So though we are created the data, it is already available in Excel format. You need not worry about. You can easily export the document. So this is a method, one method in eViews, how we can create the data file. That's all I am explaining, right? Already it is available. Okay, already it is available. You need not worry about, right? So this is a similar type of data sets. Again, I am telling you, go to click file, new work file. Then you want to create a data irregular frequency. Then you want to provide the annual data. Then or any semi-annual also, quarterly also. It is your wish. Then work file name is an optional. If you want, you can give. Otherwise, no issue. Say example frequency. If you required, then you can give as a frequency as a monthly. Otherwise, yearly. Then it will create like that. So total range will be there. This is another example. Undated work file. Suppose you want to create an undated work file. How we can create an undated work file, unstructured? Simply you can go to, see, I just close here, file, new work file. Here undated, unstructured or undated. Here you can provide observation, 50 observation. Click OK. Here it will come 50 observations. Sorry, residual. You can see here 50 observation data will become. If you are having Excel sheet, don't worry. You can directly export. Or if you don't have Excel data, then we are creating a new data set for doing an exercise. That's all. So for doing an exercise, there are two methods. One is new, go to work file. You can go to dated data or unstructured undated data. Unstructured undated data, you directly give the observation, how many data sets, 50 columns, 50 rows, like that. If you are known the date, then you click the note date. It is frequency or monthly or year, then you can check here. Say example, I want to go for monthly data, then start date would be 2005, 2010. I just click OK. If you click here residual, it will come 2005 M01, month 1, month 2, month 3, like that 12 month will come. Then again 2006, month 1, month 2, like that 12 month. So up to 2010, 12 month it will come. If you give annual, no issue. Then one more method, undated. File, new work file, undated, directly you give 100 observations. And click residuals, you may find that 100 data sets. Okay. This is the procedure only I have explained you, right? Creating undated work file. Creating a balanced panel work file also you can do it.
Sir,
Yeah.
excuse me, sir. Sir, I have a question.
Yeah, please.
Sir, how will enter the data in this file? Actually, there is NA and all these cells. So how to put the data in these cells?
I can't understand, sir.
Actually, in my sheet, I created a new file
Okay.
from 1950 to 1960.
Hmm.
And in front of the file, all cells are filled with NA. So how to fill the data in these
Yeah, I
cells?
will explain you. I will explain you, sir. I'll come. Right.
Okay.
So you are talking about how to enter the data here, right? Correct.
Yes, sir.
How to enter the data, right? We can
Yes.
enter. Right, we can enter. I will tell you, right? I will tell you, right? Okay. So this is an example of the panel work file, how we can create, right? And this is the method for using work file using commands. So we can create the work using the commands also, we can create the work file. Okay. This is all for your understanding only. And
Sir, excuse me, there's only one thing, please. If we already have an Excel file, how do we import it?
So that's why I am coming, sir. See the slide. Creating a work file from a foreign data that we have already seen also. Last session itself, I have explained you. Don't worry, sir. I will come one by one. I will come one by one. This is a method where already Excel file is there. How we can convert the work file foreign data as a work source, right? Here you are going here, file, open foreign data as a work file. Or here, if you create a open use work file, then you create a see example. I already told you new work file. Then you click like to 1965 to 1970. I click OK. And I will show, right? I will open eViews work file. If any work file is available, I can open directly. Otherwise, right? Otherwise, I'll go for file, open foreign data as a work file. Here, so many. Okay, here you can check here foreign data as a work file. Any I told you time series materials here, sorry, not time series, workshop materials. You can see check any data. You click next, finish. You can check this is a database, right? These are all the different methods for creating a file and open an existing file. So copy and paste as a new work file in eViews desktop. Okay. This is a cross-sectional work file. Also there, you can explain, you can easily do this type of exercise using a demonstration. You can do it in your home. I will send this PPT to you. You can easily do these exercises. This is the new data page, right? Load work file, right? Sir has asked about how to enter the data. This is the way where we can enter the data. I have clearly given all the instruction here. Okay. You can easily enter the data. I think Krishna Kumar sir has asked a doubt. I will send all the PPT to you. maybe end of our workshop, you can work on that, right? So if I discuss so many things for basics and all, then we will miss out on the different exercise what we are going to perform today, right? With this, I will directly take you for further analysis part, how we are going to do. So first, one by one, we can see. First, we can see that symbol linear model. Okay, symbol linear model. Hope everybody have installed the software. Hope everybody have installed the software. Anybody have any doubt in installing the software? Let me know. Let me know. Anybody have not installed the software? Okay. Hope everybody have received the data set. I'm sorry. Yes, sir. Thank you, ma'am. Thank you. I think everybody has installed the software. Thank you. Very good. Rohini ma'am asked about serial number. I have clearly explained already. You can also check it with the mail also, spam box also, right? Thank you. Okay. You can also receive a Google Drive link for accessing the data set. Accessing the data sets. Here data file, there is a one data file. Okay, there is a one data file consists of ARIMA, multilinear, symbol linear, stationarity, and where exam, etc. Now, first we are going with the symbol linear analysis. Symbol linear analysis. Symbol linear analysis. Okay. First to open a eView software. Click OK. Open a foreign data. Open a foreign data as an Excel file. Click the folder where you have saved all data set. And click symbol linear. Symbol linear. Then click next. 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 Then finish. Then link imported series and alpha object to external source. Yes. Okay. Oh, what happened? I am not sure. There is some. Okay. Series 3 also. Okay, done. I'll once again check it. Symbol linear. Okay, 1 second. There is a something. So it should be pasted here somewhere else, right? Okay. Dear friends, let me know that first time before going to open a eView software, I have closed eViews. Let me open first. You can open a data file. You can open a data file and open a Excel format. Symbol linear. Click open with Excel. Don't open with eViews. Open with Excel. You may find that file. And if you have first line, you can cut and paste it somewhere else. Okay. This is actually annual per capita consumption. Annual per capita consumption Okay, consumption expenditure. PCEXP means everybody is following. Everybody is following. Please let me know.
Yes, sir.
Yes, sir, we are doing.
Yeah, PCEXP means annual per capita consumption expenditure, and PCNSDP means annual per capita NSB of different states. And this is a source I have received from RBI website. It is not required, right? So first, when you suppose if you have this information, first you can cut and paste it in somewhere else. Okay, somewhere else, and save the file, and close it. Now you open eViews, select open a foreign file, or if you close, then you can go file, open foreign data as a work file. Similar manner you can follow any systematic pattern. Go to desktop and time series by I told you WhatsApp material and symbol linear. Then I am click next, again next, then come to finish. You link imported, yes, right? And automatically this series has generated. So previous thing, why is the series was generated? Because we have given the series name at the first column. Some description part we have given in the Excel. That's why it is not created. So that's what I asked you to cut and paste it in somewhere in the Excel format. Now the series is created. Hope you have seen the series as PCXP and PCN SDP, right? Okay. This is the state. Now what we want to do, I told you it is a simple linear regression model. First thing, we want to generate the equation. Go to quick, estimate equation. There is a formula here, estimate equation. Here you can write PCEXP is your dependent variable. PCEXP here, PCEXP is a different variable. Then constant, space constant, then space PCNSDP. Okay. Constant or intercept. C means constant or intercept. PCEXP, intercept PCNSDP. PCNSDP is an explanatory variable and PCEXP is a dependent variable. Okay. Then click OK. Then click OK. This is a simple linear. Output will come. Here you can check that how we can write the formula. If you want, you can quote out. PCEXP is equal to PCEXP, different variable, is equal to, that is coefficient constant, 9311.181 plus, okay, PCEXP is equal to, yes, once again, I am writing the formula. Once again, just a second. Here I am writing, okay, this is an PC, just a second. This value, right? Oh, sorry. PC EXP I'm sorry. Shall we proceed, sir? I'm sorry.
Yes,
Yes.
sir.
Okay, okay. The PC EXP is equal to 9311. Sorry. Second. 9,000. Okay. 9,311.181 plus 0.151035 PCNSDP. So this is the written here, right? You can check here. I'll minimize. I'll minimize and show you. Oh, this is the value 9311.181 plus 0.15 0.151035. So different variable y is equal to a plus bx, right? A plus bx. So that is the value I have tell you. And one more thing, that in the probability it is given, it is less than 0.05. P value is less than 0.05. Okay, p value is less than 0.05, hence it is statistically significant. So it is a 0 point probability value is here less than 0.05. Okay, p value is less than 0 point, then we came to know that it is statistically significant. Statistically significant. Okay, then this is, I told you, PCEXP is a formula, writing equation 93, that is a constant value, coefficient constant 9311.181 plus the PCNSDP value 0.15, right? which means per capita consumption, that is PCEXP, per capita consumption expenditure is positively related to per capita net state domestic product, PCNSDP. The per capita consumption, PCEXP, is positively related to per capita net state domestic product, PCNSDP, which you also find that R square value is 0.686860. See, R square value is 6860. That is R square value. R square indicates, right, which means around 68 to 69 percentage, 69 percentage of total variation in PCEXP has been explained by PCNSDP, right? R square, that is this value, R square, it indicates 69 percentage of total variation in PCEXP has been explained by PCNSDP. So this is the formula. Y is equal to, that is PCEXP is equal to this value plus this value, PCNSDP. So here it is a statistically significant. This is a simple linear formula, simple linear equation using E-views. Any doubt regarding that? Anybody have any doubt? Hope everybody is following.
Yes, sir.
Thank you. Anybody have? Shall we move to next one, sir? Shall we? Yes, thank you. At least you can, if you are not possible to respond, please send the message itself. I will be able to follow. Right. Thank you. Okay. Thank you. I'll go. Yes, sir. Thank you. I will go with the next one, multiple linear regression model. Before that, I can check with that. The data set of multiple linear model. You can close it, or no need to save it. You can just close it. No.
Sir, may I interrupt?
Yeah, please.
Sir, which one are we supposed to check? Is it R square or adjusted R square?
R square.
Okay.
R square. R square means how much it is influence on the dependent variable. How the independent variable is how much is influencing on the dependent variable.
Then what about the adjusted R square, sir?
It is not required, ma'am. If you don't want, you can also check. There are so many methods for writing an interpretation.
Okay.
I have narrated with the statistically significant. We check with the p-value. We also return that formula. Okay, R square. If adjusted
Right.
R square also, if you want, you can check it. No, not an issue, right?
Oh, okay.
You can close.
Sir, I have one doubt, sir.
Yes, sir. Please.
How we can take this result to the word sheet?
I can understand. What? How?
How we can take this result to the word format, word sheet, copy to.
Yeah, you can copy it and paste it, or you can save it in even e-views format. You can save it as in e-views format. When you close the file, when you close the worksheet, when you close the output file, they ask whether you wish to save. If you want to save, you can save it in e-views format itself, or you can right click, copy, save it in Excel, or save it in Word. Or I will.
Okay.
One second. I will tell you. Suppose I required this file, correct? You are asking about something related to this file. Okay. This file, right? You doing some grep. You just click copy to clipboard, right? Copy to clipboard. right? Copy to clipboard, then save it in the disk, or save grab to disk. So much of methods are there. So many methods are there. This is all symbol method, right? Right. Coming to that, again, I'm going for multiple linear model. You can check that data file, multiple linear regression. Oh, one second. Sorry. I'm sorry. You want to check before that, open with Excel, Microsoft Excel. Again, it is exist here. So I want to delete this file, unnecessary column, then copy it here. Copy it and paste it here. Now I am delete here. Okay, now here also you can copy it and paste it here. Okay, right, done. So this is an data set for multilinear regression model. Multilinear regression model. TFR means total fertility rate. Total fertility rate. Then female literacy rate. Female literacy rate, FLIT. FLIT means female literacy rate. Then urban means percentage of urban population, and poverty, that is headcount poverty ratio. So these are all the data are given here. So if you are having some information here, you just copy it and paste it somewhere else. Now you can close the Excel file. Even directly from Excel file you can open. Right click, open with eViews. That is automatically open. Or you can open the eViews, then click foreign data as a work file, then you can do it. Next, finish. You can import series, yes. Now you see that fleet data, poverty data, state, TFR, and urban, everything will be displayed here. Okay, you can check if you want, you can check with open with Excel. Okay, these are all the 4 data. Okay, this is an eViews file. For your understanding only, I have make it here. So totally 4 data. Here, what is a dependent variable is a TFR. Total fertility rate is a dependent variable. Total fertility rate is a dependent variable. There are so many independent variables. One is a female literacy rate, then poverty rate, and urban population. It based on total fertility rate will be decided. Then what I should do? I want to write the equation. So again, as usual, in simple regression model, simple linear regression model, I go for quick estimate equation. Quick estimate equation. I am writing that TFR, total fertility ratio, space constant, space flit, space poverty, space urban. Okay, total fertility rate constant, flit fertility rate, I mean flit rate. Flit, what is flit? I told you already. Then poverty, then urban. Poverty rate and urban rate. Then click OK. Click OK. You will check this. You will check this. You will. Hope everybody is following. Excuse me.
Yes, sir.
Okay, thank you.
Yes, sir.
Okay, thank you. This is, I'm sorry. This is an output. This is an output. I am going to write how I can write the formula here. I will tell you. I'm sorry. And yes, here I am writing formula TFR. Okay, TFR okay, TFR is equal to 4.738573 minus flit value 0.047318 flit. Continuously we want, right? Plus 0.013899 power t minus 0.000988 urban. Okay, this is the formula, right? This is a formula. This is a multilinear equation, multilinear regression equation, Okay, this is a dependent variable. This is a dependent variable. This influences on this one, and this one, and this one. So, which means here you can see that here, when you check here, in the probability value on FLIT, poverty, and urban, the three independent variable, you can see that only female literacy, FLIT here 0.0005 is only appears statistically significant because the significant value, that is p value, is less than 0.05. Here 0.0005, 0.0005. Okay, so p value is 0 point. So p value is how much? 0.0005. Only in case of FLIT. So that is statistically significant. What about others? So poverty is not statistically significant. Urban is not statistically significant. Why? Because the other variables are not significantly significant because p value is higher than the 0.05. So according to R square, that is 71% is the variations in fertility rate. So fertility rate is depends on other independent variables on 71%. Okay. Hope everybody has understand.
Yes, sir.
Okay.
Yes,
Sir,
sir.
sir, I have a question
Yes, please.
here. Sir, we are running this model in this analysis. So why we are not testing for the normality and stationary in this, all the data sets?
Regression it is not required. Regression it is not required. I'll come, sir. I'll come. Next only we are coming on stationarity. Regression is a basic, right? If you want, you can do it. Not an issue, right? Not an issue. But regression is not required. I'll come. It is a wonderful question, sir. It is a wonderful question. Okay, next, shall we move to next one?
Yes, sir.
Is it okay? Shall we leave it break for 1 o'clock? Is it okay all?
Yes, sir.
Okay, fine. Thank you.
Yes, sir.
So now come to that testing the stationarity. There is a one data set called stationarity. I'll check with the Microsoft Excel. Anything is there? Yeah. Here also there. Why? Because in title it will not accept in eViews. Okay, that's why we want to paste it somewhere else. Otherwise, the data did not. Sorry. Data is not possible to convert. That's what I save it in somewhere. Here also I just cut and paste it in somewhere. Then I delete this entire column, right? So consumption is there, GDP is there. Data on GDP and consumption expenditure for India is given here. Okay. So I just make it save. Then I want to now again go for eViews. Click OK. Then open as a foreign file. Select the respective folder. I click data file. I click the stationarity file. Then click next, finish. Okay. So what I should do? First one, there are different methods are there. First one, we want to transform the GDP series into logs. Okay, transform the GDP series into log series, so that we can easily adopt the different analysis. Okay, here what I am do, this is a GDP series. I want to transform into log. I want to transform into log, GDP series into log. Then only we can able to do lot more analysis. What I should do, first one, you can go to gender. Just a second. Okay, transform series is main gender. Okay. Here it is there. There is a one option called general. Okay. Click general. Enter equation. You are creating a new data file. Okay, this is a GDP file. You are creating a new GDP file, logarithm of GDP file. Okay, generate, then enter equation. L logarithm of GDP new series is equal to log of GDP. Once again, I am explain. After open that GDP data, or you need not open a GDP data. Okay, you need not open the GDP data. From the work file stationarity window, click generate and write the new series name LGDP, logarithm of GDP is equal to log of GDP. Then click OK.
So I didn't have generate file.
Yeah, you can create it, generated here, right? So new GDP has generated. This is a log of GDP. This is called as a differencing. Log of GDP is we have created. Now you can go to view, check the graph. This is a trend. The data is not stationary. Again, go to view. I go a little bit slow. Open LGDP. First, we have created a new data with the differencing method LGDP. Then we have found that graph method, it is not a stationary. I have also told you to check one more method called Carlogram. You just check Carlogram level 1, click OK. Again, it is a spike. Okay, again, it is a spike. So the first two column of Carlogram graphically display autocorrelation, AC, this is autocorrelation, and partial correlation, partial AC of the LGDP series. It appears from the Carlogram that the AC starts from very high value. This is AC start from very high value at lag 1 and declines gradually and decline. This is our lag 1, lag 2, lag 3. AC starts from high value and decrease gradually, right? So AC is up to 12. So here this point, you see, this is up to 12 lag. You see that up to 12 lag, it is statistically significant. See, when you look at this 13th point, this is significantly different, right? AC value. So up to 12 lag, it is not significantly, I mean, statistically up to log 12 are statistically significant. All these suggest that the LGDP series is not stationary. Or even you can see that in the one spike from the partial correlation itself, you may know that it is not stationary. So two methods we have done. One, so you open LGDP, first view, graph, do it, then you came to know that it is not stationary. Then again from the same window or go again further, go to view, Carlogram, and you came to know that it is not stationary. What we should do again, we should go to conduct ADF test, ADF, augmented Dickey-Fuller test, unit root analysis. Then go to view, unit root test, standard unit root test. Then first level, then it is, you can click none intercept, anything is there, you click in intercept, OK. So probability value is 0.9991. So it is not a stationary. Okay, the probability value should be less than 0.05. Then only it is a unit root. That's not unit root. Okay, then what we want to do? View, unit root, standard unit root, first difference. Click first difference. Then click intercept. Actually, we don't have any trend. If you want trend also, you can, no problem, because when we check with the, because how we can use a trend, I will tell you, sorry. When you use the graph, you can see that there is a trend is there. So then if it is a trend, then you can click unit root, first order, first level, trend and intercept. You may not get trend and intercept. Here again you go to unit root, standard unit root, again first order difference, you click trend and intercept, because in the graphs we found that it is a trend. Otherwise you just click intercept. If you found in the graph it is there is a upward movement, then you click trend. Otherwise you just click intercept. So graph we can see that we found that it is a trend. So click trend and intercept, first difference. So though in the first 0th level, probability value is 0.988, first order level. I mean p value is 0.999, right? 988. It is greater than 0.05. We accept null hypothesis. Okay, and accept null hypothesis, and we conclude that LGDP has a unit root and is a non-stationary. Okay, here p value is greater than 0.05. I will write once again from the LGDP view unit root, standard unit root, level, intercept, and okay, you find this answer. Then what I want to write here, you can open for your explanation. I just write you. Here I am writing. Here in the first result, p value is greater than 0.05. So we accept null hypothesis. We accept null hypothesis means LGDP has a unit root. What is LGDP has a unit root? It is a non-stationary. LGDP has a non-stationary. Okay. So, okay, right? What we should do again? We should do again. Go to view, unit root, standard unit root. Click first difference, then click OK. Now you find that p value. What is p value? That is 0.0000 is in the first difference. This is first difference, first order difference. P value is less than critical value 0.05, significant value 0.05. So it is stationary. What is stationary? Means we reject null hypothesis. So we reject null hypothesis. Here I told you, here check here, null hypothesis has a unit root. We reject null hypothesis means there is no unit root. There has no unit root. If there has no unit root, then it is stationary data. It is a stationary data. Anybody have any doubt so far?
Sir, I have beginning doubt, sir.
Yeah.
How to convert the data to the log data?
Oh. That's I told, no? Go to eViews. Okay, I will close this file. I will tell you. Delete it. I just delete it. Okay, I just delete it. What I do, you go to generate. Here you create LGDP is equal to.
Where is generate? Is there generate?
Sir, here it is there. No, you check here. GENR. Sir, in the window, can you able to see my cursor? Excuse me.
Sir, I seen it, sir. I seen.
Have you seen?
Yes, sir. Yes, sir.
You click generate, right? LGDP is equal to log of GDP. Click OK. That's all. Fine. Now everything is fine.
Thank you, sir.
Yeah. Anybody have any doubt? Again, Keshav sir, I have already told you again for a log GDP.
Sir, I have a doubt here.
Hmm.
If we are going to take the data, especially the financial data, take the log of it, or maybe we take first differencing or second differencing and all that. Further, when we do the analysis, the essence of the data is lost, right?
Essence of data
Is lost, correct, no,
okay.
sir? If we
Oh.
convert it so much,
okay, I understand. Tell me, ma'am.
That's what, if we are going to convert it so much of conversion if we do using log and differencing, then the originality or the essence of the data is not there at all.
No, ma'am. Actually, the condition is like that, ma'am. I also have similar doubt, as you all clearly mentioned that. But we don't have any option. But because when we read any books or any articles and all, definitely when we use any econometric model, we should do only the stationary data. Okay, non-stationary data we cannot do for further forecasting and all. It is not possible. So you can do it with GDP series itself. It is not an issue. But the differencing method will be very high. The trend will be very high. In such case, the forecasting is not possible. Okay, the forecasting will not possible. So we have used only a small amount of series data. When we use the large amount of data series, that would be a crucial problem for the researcher for doing a research. So now we are practicing on only very small data set. But when we use a large data set, then there may be some problem over there. So that's why we are using, first we are creating the logarithmic of data, then we are converting into different methods of stationarity. Then we prove that all the method in graphical method, in the parallelogram method, and the unit root method, if it is not not stationary, then we make it as a stationary for further doing on analysis. So that is a method, ma'am. And again, I will tell you, my dear friends, a similar method we can follow for unit root, standard unit roots. I use that ADF. Instead of ADF, you can also use Philip Perron. But somewhat the value will be different. The value will be different. The analysis will be different. Here it is a unit root. PDF has also an unit root, null hypothesis. But I told you there is a one test called KPSS. You just note out null hypothesis has an unit root. Here, you just for understanding, KPSS, yeah, what it is given, it is stationary. The null hypothesis is just an opposite. Null hypothesis is just an opposite for KPSS test. Okay, but it is all you can do only the ADF. It is more than sufficient. More than sufficient. So many research paper I find that.
Excuse me, sir.
Yeah,
Sir,
please.
to check the unit root, we can use any one of the method, no?
Correct,
ADF or
exactly.
let's say one or
Exactly.
KPS.
Yeah, correct. You can check any one, but most of the papers suggest that ADF is the best
ADF.
method.
Yes,
Correct?
sir.
ADF is the best method. And that's what I just want to point out here. In many research paper in econometrics, there are some researchers who only use the tool unit root analysis. There are many researchers only use the tools of unit root on different methods, and they have come up with the result. They have come up with the result what are all the merits, why this difference is there, and they have come up with the fruitful findings also. They have used only unit root for measuring some series. Okay, that is also possible, right? That is also possible. Correct. Okay, yeah. Now I'll just stop here and I will go next tool. Next tool. Same data file, I think so. Stationarity co-integration. Yes, we are going now co-integration. We are going now co-integration test.
Sir, one more question on stationary. As we have applied log for GDP, and if we found other variables non-stationary, do we have to do the same for all in the same
Yeah,
order?
we can do. We can do.
Okay.
When we take in for others analysis, I just
Yeah.
consider only on GDP. One for stationary. I just used for one model.
Yeah.
Okay, you can
Okay.
do it on other analysis also for two series, 3 series, etc., etc. Okay. Shall we go for next slide? I mean, next analysis.
Yes, sir.
Okay, I'm using the same data, stationarity. That is an consumption. Okay, just a second. This is data on GDP and consumption expenditure in India. Data on GDP and consumption expenditure in India. I am going to use the first co-integration method, like we called as Grangler, Grangler method. Okay, Ingle Grangler method. Next, finish. Click yes. Then I'm going to generate equation. I told you L GDP is equal to log of GDP. And I also using consumption as CONSU, right? Again, generate LCONSU consumption is equal to log of CONSU consume. So I have generated two series. Both are, now you can check. I think Jnana Subramaniam sir have some voice, right? Can you, sir, Jnana Subramaniam sir? There is some disturbance. Okay, thank you. Now check with LGDP first one. So yes, I already told you the same series, unit root, standard unit root. When we check with the intercept, it is not stationary. Then we go to unit root, standard unit root. First difference, it is a stationary. Okay, first difference, it is a stationary. Okay. Since and we also check with the L consumption also, view unit root. I'm not repeating all the procedure, parallelogram and graphs. I'm directly go to unit root. Standard unit root, if you go with the level, it is not stationary. Again, with the level, not to level, I go for first order, first difference. then it makes stationary. So we come to know that since both are difference in the first level, okay, when both are in both the series LGDP and L consumption, SU, right? And sorry, SU are stationary, okay, are stationary in first difference. So since both are, that we call in the mathematical derivation, we will write like that. I is equal to 1, first difference. We can run first symbol OLS. We can run first symbol OLS. Symbol ordinary least square regression. So what we want to do, using LGDP, we can estimate the equation. Okay. So what we want to do, we can write estimate, where is it? Quick estimate equation. Right, LGDP constant C LGDP C LCONSU and click OK. This is the result of symbol OLS between GDP and consumption. So here you just generate the series, results of OLS will be displayed. This is the results of OLS. Now, for a co-integration Granger model, Engel-Granger model, we want to generate the series for residuals. Okay, generate the series for residuals whose stationarity needs to be examined to whether there exists any co-integration is valid or not. Okay, for that, what we want to know whether there is any co-integration is available in the data or not. We want to check. What we want to do from the output, we want to go for, there is a one method called resides. Sorry, not reside. I'm sorry. Oh God. Quick estimate option, LGDP constant cons, click OK. It will come. Okay. Now we want to go with the click procure. We want to check the residual value. Click procure, make residual series. First, we want to check the residual value from the OLS output. Ordinary least square regression model output between GDP and expenditure. We want to click procure, then make residual series, click OK. So now this residual value will be displayed here. So how to save? You go to object, How to save object store to DB, store to DB. You have to name it is residual, right? You have to name it is a residual. RES. Any name you can give. It is residual. RES. REX. Then click yes. No database was specified. Okay. Object store to this one, store in object store to DB. Okay, database name res. Click okay. Otherwise, calculate residue 01. Click OK. Oh. Database was not specified. Correct. Press browse.
Sir, we need to change the database, sir.
Correct.
The
So
option for the database should be individual, then it will keep the location.
I will tell you
So here,
how to save.
Here it's not asking to open it.
Yeah, I will save it in the desktop. Residual open. No,
sir. It is asking a location, sir. Actually, you need to change store in to the individual. Yes.
Individual.
And now browse if you want to select any location.
I will leave it, right. I will leave it again to desktop, right?
Yeah.
Yeah, correct, exactly. Desktop, then click save. Oh. Yeah, save. It is saved. Okay, it is saved. So now we want to check the co-integration of. Now we can check the co-integration, consumption of expenditure and income. Okay, and you just close it here and view this. I mean, from the ADF level, view and unit root, standard unit root, right? Yeah, here itself it is a 0.05. 0th level itself it is a 0.05, less than 0.05. Okay, so which shows that residual series is stationary in level. See here, view unit root, standard unit root, level itself in residual value. In residual value, the probability level itself it is less than 0.05. So this implies that there is a co-integration between logarithm of consumption and logarithm of GDP variables is valid. We conclude that. So we created residual value, and from the residual value we come to know that so residual serial is stationary in level. So you just check here, probability value 0.04 is less than 0.05. So it is stationary. So this implies that there is a co-integration. This implies that there is a co-integration between L consumption, logarithm of consumption, on LGDP variables is valid. So what is co-integration? Actually, co-integration is a statistical method used to test the correlation between two or more non-stationary time series in the long run or a time period. Once again I am explaining you for the researcher why we want to check the co-integration, maybe long run or short run. So co-integration is a statistical method used to test the correlation between two or more non-stationary time series in the long run or a particular time period. So since co-integration has become possible in such case, in this particular result, we can proceed to estimate the ECM. So we have decided in the residual, from the residual value, we come to know that in the level itself, the data is stationary. So it is a co-integration between consumption and GDP. So now we want to proceed with the error correction model, ECM model. So since co-integration has become possible, we proceed to estimate the error correction model. Error correction model is a ECM model. Okay, we are going to estimate the error correction model. How to do the error correction model? You can check with a quick estimate equation from the output itself. You can check with a quick estimate equation, write D difference of L consumption and space C and D of L GDP and residual is -1, right? Residual is -1. L D difference of consumption, C difference of LGDP. Okay, difference of L consumes. Oh, I'm sorry. SU. Not M. Serious name will be. You should know. Always note out the serious name. Otherwise, the result will not be displayed. L consume, logarithm of consume. C D log of L GDP. RES, not residual. RES -1. Okay. Then click OK. Oh, residual is not defined. Once again, RES okay. I'm sorry. So this is the value. I once again I will tell you. I written that formula is wrong. Go to quick. Generate estimate equation. We want to write D difference of L CONSU consume, then constant, then D of LGDP, right? Then residual error. I think this is 0, 1. Residual 0, 1. This is the series we have created. -1. Click OK. you will come this result, this out box. This is output box. So these results are quite satisfactory. These results are quite satisfactory, especially because of this value, residual minus 1, 0.303401. So it is a minus value, right? Minus value is negative and statistically significant. Okay, minus value is residual value is statistically significant. Okay, so we conclude that it is a long run relationship of the variables. So long run relationship of the variables. Okay, I will stop with this, and after lunch break, for your understanding, again I will once again I will work out on co-integration. Then I will proceed with the further more analysis. Right. Once again, we will go with the co-integration model. Then we will go with the some more analysis. Right. Okay. If you have any still queries, you can ask. So this is a co-integration in Engel-Grangler causality model. So there are so many models, Johansson correlation, so many model, but I take into consideration on this model like Granger-Engel model, EG model. So the Engel-Granger model. It is one co-integration model. We conclude that there is a long-run relationship between GDP and consumption expenditure. Okay. So what we want to do, first we want to transform the series into logarithm series. Then we want to estimate the formula for using OLS. Then we convert to residual value. From the residual value, we want to identify the ADF test. Then from the ADF test, again, we want to go for estimate the equation. And we can conclude that it may be a long-term relationship. Okay. So thank you. You can stay in the line. We will not close the session. Maybe exactly by 2 o'clock, we will start our session. Okay. Any specific doubt we will have? Otherwise, I will start with once again quickly on co-integration. Then we will move on. We have so many tests, ARIMA, and we also have after ARIMA, we have forecast WAR model, and we also have car charts model. I don't know how many tests we are going to proceed anyway, because these are learners. I cannot go quicker also, but maximum time we will take up to 4:30. How much possible we will handle.
Sir, I
Thank
have
you.
one request actually.
Please.
No question, but one request.
Yeah,
After this session, sir, could you please give us some sources where we can download the data?
Yeah. I will down.
Open
Yeah,
access.
please. I will do it. I will give it.
Sir, you
Our
will you please send us
I will,
all the recordings of the whatever you taught today? Will we
ma'am,
have a
definitely.
recording of it?
Definitely, I will post it in the YouTube. At any point of time, you can refer the material and you can see the
I
video.
missed out some of your lectures because I was out. So please, it will be great if you can send us the recording of it.
Yeah, that's what I told you. I will send the full record and I will post it in the YouTube. Don't worry about it. At any
Okay.
point of time, you can see the video.
Okay, one more thing, sir. Whenever we apply any test in eViews and the result, if we want to paste in Excel, so it always pasted in picture form. Why not in Excel? So please tell this also after the break.
Ma'am, what is it? Why?
Sorry, sir. Actually, I have applied a test. Like for example, uh, statistics or descriptive statistics I have applied on a series, and if I pasted that particular thing in the Excel, but it's always pasted in picture form in EViews 12 version. So I will be with that also. So could you please explain this one after the break?
Okay, I will try, ma'am, because I am also not a technical guy. Anyway, I will try. I understand
Okay.
your queries. I will able to solve.
Yes, sir. Yes, sir. Thank you, sir.
We will meet exactly by 2 o'clock. Thank you all. Dear all, shall we start?
Yes, sir.
Okay, thank you.
Yes, sir.
Yeah, once again, I will explain you the co-integration. Then we will move to next test. Okay. And for doing co-integration, I'm just sharing the screen. You can open eViews, then go to open foreign data as a file, then respective folder. You can go to time series. I have told you to open the stationarity co-integration data, and then click next, then finish. You just click yes. Then what we want to do first one, we actually, it is a two types of data. One is a consumption expenditure and another one is a GDP, right? GDP, right? Then what we want to do, we want to go for Engel-Grangor method. Then we go for quick estimate equation. Okay. Okay. No, sorry, not estimate equation. First, we want to go for generate the enter equation. LGDP is equal to log of GDP. Then we have created on this one. Another one, again, we go generate and LCONSU. L consumption is equal to log of CONSU. Right? Then click OK. The two data we have created, and so we already explained you both LGDP and L consumption. LGDP and L consumption are both not stationary, so that's what we are make it as stationary in the first difference. So once again I will tell you this one, we make it as unit root standard, then first difference we already known that. Similarly for this one also, LGDP also we make it as standard unit root first order difference. So this is also stationary. So then both are in I of 1. We want to run first simple OLS method regression, simple OLS regression of the LGDP with the estimate equation, right? So what we want to do, first one, you go to quick estimate equation. Then we want to write LGDP constant and LCONSU. It's okay. LCONSU. Then click OK. So result will be displayed. Both are probability. So generate the series for this. We want to create the series of residuals. We want to create the series of residuals where we want to check the stationarity, whether the stationarity is exist. Then only we can assume that the co-integration is valid. So for that, what we want to do, again, we want to click the pro. Then we go for make residual series. Then click ordinary. Okay. So we can provide the name of the series to res. Then click OK. Okay, then you can go to save. We can go to object, then store to DB, then receive. You create individual data file. Then it is automatically can save in some file. Okay. Then what we want to do? Then again, we want to check the stationarity for resident value. How to check the residential value stationarity? That is nothing but is you got that ADF test, unit root ADF in level itself, right? In the level itself. Yeah, now it is 0.0436. Now the value is 0.436. It is less than 0.05, less than 0.05. So this implies that the co-integration between logarithm of consumption and logarithm of GDP variable is valid. So I have told you already that co-integration means it is a correlation between two or more non-stationary time series in the long run or a particular time period. So since we have identified that it is a co-integration is valid in this particular level, we want to go estimate the ECM. We want to estimate the ECM, that is error correction model. So how to find out the error correction model? Then we go to quick then estimate equation. There is a one option called estimate equation, where we have to find the difference of LCONSU consumption, then constant space D of LGDP, then or residual we check -1. Okay. Okay, then value will become here. The output result will become, the results are quite satisfactory. Okay, the result are also quite satisfactory. And we fix that it is a long run relationship is exist. Long run relationship is exist. So this is the test of co-integration as per the Engel-Granger causality method. That is mainly we are going to test this test for relationship between, particularly long run relationship between the two variables. We have checked with the two variables. One is a GDP, another one is a consumption pattern. Okay, and I will close this one. Next test we are going to see is ARIMA. ARIMA. Yes, sir. Any question?
Yes, sir. I have a question, sir.
Yeah, please.
So, as you transform the data into log transformation, so what is the criteria to use the log transform data or normal data
Can
you
you
use in this analysis?
can you little bit loud, sir? Please, I can't understand. Can you little bit loud?
Actually, sir, you transform the data into log transformation for this analysis. So, what is the criteria? So, we will continue with the log transform data or with simple normal data.
No conditions, sir. Actually, the way we are going for logarithm. See, logarithm means we can find out the data difference, right? So difference, we want to find out the difference. That's what we are going for a log. So we want to convert both consumption and GDP in the log. That's what I have already explained in the previous test itself. We have transformed the GDP series into log. Because we want to identify the difference. So difference will be minimum, no? That's what we want to go for logarithm. So if you go for the logarithm, then we can find out there is a possibility of the stationarity. There is a possibility on the stationarity at level itself.
Okay, sir. And I have another question. When we transform in the log and we have multiple variables, say 2 and 3. So is it necessary to convert all the data series into log transformation, or we can convert?
When we make a relationship between the two variables, then we want to make it's two. See, actually, unit root is not a matter, right? See, suppose we are going to identify the relationship between the two variables, then we should definitely use the formula in the quick estimate equation, right? Estimate equation, quick estimate equation, where we want to write in both the variables. One is a dependent variable, one is independent variable, and in between that we want to write the constant C, intersect value.
Okay, sir. And if we use the log transform data for any model and analysis of, for example, you used it for your regression analysis. So the interpretation of results will be different with the log transformation.
Yes, yes, definitely. Definitely, sir.
So what will be the difference? Can you explain this thing in little
Which
bit
one? Which
detail,
one?
sir?
Which one, sir?
Actually, we are using the data with log transformation, and
Hmm.
in another analysis, we are using the normal data without log transformation. So,
Hmm.
what will be the interpretation of results
No, no,
and
no.
difference between?
See, mostly we are using logarithm. Only I told that regression we are not using logarithm. Okay.
Okay, sir. And sir, please suggest some extra resources for more
See,
clarification. Can
once again,
we
once
can?
again. See, whenever you are using original continuous data, do not follow the bell curve. Bell curve I have explained. No, whenever
Yes, sir.
I mean when our original data do not follow the bell curve, then we can go for log transformation. That is a simple logic. So
Okay.
when we draw the diagram in the graphical manner, sometime if in the graphical manner, if it is not to follow the bell curve, then we can go for log transform the data. Then it is possible to make it as a normality. First itself I have told no. First itself I have told. So again I am explaining you when our original data we called as a continuous data do not follow the bell curve, then we can go for log transform the data, then normality is possible, so that statistical analysis can result from the data itself and it may be varied. In other words, what I am trying to say, that the log transformation is reducing or removing the skewness of our data. Log transformation of the data will reduce the or remove the skewness. You know that what is skewness, right?
Yes.
Skewness means like a distortion, distortion or asymmetry of a data set. Okay, one side
Okay.
it fall.
Okay.
It may be either left side or it may be in right side. I mean, as a symmetrical distribution or asymmetry in a data set. Okay,
Okay, sir. Okay, sir. Thank you.
hope you understand.
Yes, sir. Thank you, sir.
Okay, thank you, thank you. So that's why we are going for log when the data is not fall in the bell shape. Okay. I think I have explained. Nana Subramaniam, sorry, told you to explain the co-integration because we identify from the co-integration result both are valid. Okay, both are valid. That's what it is explained about both. I mean, the GDP and LGDP. I mean, sorry, GDP and consumption. Both are stationary. Both are stationary in the residential series. Then we came to know that there is a existence in the co-integration. When at the time of the calculation of residence series, we identify in the residential series the order level itself. It come with the stationary. Then we have decided that co-integration is implied between LGDP and L consumption pattern. That's why we have make an equation in the co-integration format. We gone for the quick and estimate equation of both difference of L consumption and difference of LGDP with the residual also. Then the output is also satisfactory. Okay, output is also satisfactory. The probability is arrived. The probability value is less than the 0.05. Then we conclude that there is a exist in the relationship between the two variables. Okay. Okay. Now we are going to discuss on ARIMA. We are going to discuss on ARIMA model. So file, open foreign data as a work file. Then we go for Arima. Okay, Arima, we have wheat, rice, and total food grain. 3 datas are there. Then click next, 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 finish. Click yes. So what we want to do first, we want to open a wheat data. Okay, and then we can check the graph, right? Then we check descriptive statistics, histogram. Sometime it is also not in logarithm, but we will do it later. Then what we want to open a wheat, right? View parallelogram also. Yes. You can check that in ACF of the series in Arima, ACF autocorrelation, it exhibit the dying out. Okay, significant ACF value, autocorrelation value. Okay, this significantly, there exists a significant spike, and in partial correlation, PACF, only one lag is spike, remaining are not find out. So wheat is now stationary. So wheat is not, so not stationary, it is non-stationary. Wheat is a non-stationary data. So what we want to conclude, we want to go for view, unit root, standard, level, intercept. Yes, 0.94, it is non-stationary. What we want to do again, we go to view, unit root, standard, test, and first difference. Okay. Then it is stationary now. It is stationary now. Okay, ACF series has a significant spike at lag, and now it is stationary. Then you can go to again view parallelogram, first difference, click first difference, okay. Right, first difference and okay. You find that, see, you can see that view, unit root. I will show you the two difference. Level 1, you can see that this is level 1 and their level 1 parallelogram. Level 1 parallelogram, you cannot find no spike at all except one lag, first lag in PC, except P in partial correlation, ACF, right? That is autocorrelation. This one is autocorrelation. Another one is a partial correlation, PACF. Except one, all are nothing there. So non-stationary. So what I have did, I have asked you to go for unit root test, first difference level. Then we find that probability is arise. Then again we are same data, we are going to go for parallelogram. Then first difference, okay. Then we have found that the data is stationary now. From the data stationary, in the lag 10, we have found one spike. Here is 1. So it may be the Arima model of 1 1 or 1 1 0, 1 1 0 or 1 10, 1 1 10. We will check it later. So what again we want to do again? We can select. We can go for this, select this one, wheat, then select again. So from this curve to, we come with the work file sheet. We select PRQ, then go to work file structure, work file structure, work file structure. Then change it as unstructured. Unstructured. Suppose already 41 observations are available. Then what we want to do, we are going to forecast another 3 more series, another 3 more observations. Then add 3, we have to know 44 observation we required answer. I mean forecast the figure. Then click OK. And it will ask about resize involving inserting 3 observation. Is it so? Then continue. Click OK. Then if you click wheat here, you will find that this data set 42, 43, 44. Okay, you will find the 42, 43 and 44. Okay, this is first step. Okay, first step, I will explain you 1 second, don't worry. Then go to quick estimate equation, write D of wheat, then C constant AR1, AR1, yeah, 1 spike. Okay, then MA 10th lag, 10 lag, no, 1 lag, first AR 1 lag and MA 10. Then click OK. You will find the result AR1 and MA10. Probability value is arrived. Okay, probability value will arrive here. AR1, MA10. Probability is also come. And I ask you again, if you want to check, you can from the output window itself, you choose forecast. You choose forecast, then forecast level. It is a forecast. Forecast name is also there. Wheat F, method dynamic. Okay. And graph is also forecast. So as usual itself, you need not change anything. Okay, forecast name, for new forecast name wheat F. Then click OK. Once again, I explain you. Go to quick estimate equation. From the equation, you write D of difference of wheat space C space AR1 space MA, AR1 and MA. MA means the PACF. Okay, PACF 10th lakh MA, and from the ACF we find that AR 1 spike and MA 10th lakh spike. Then we put here OK. We found this is the answer. Then from the output window, go to forecast and check that it is a dynamic method. The new forecast name is VTF. Then click OK. Click OK. Then this is the value, forecasted value VTF will be displayed here. Root mean squared, mean absolute error, tail inequality coefficient, everything will be displayed here. And whether to obtain forecast levels of wheat production 3 years, and what we should do, you can minimize one, you check here this one VTF. Okay, you click VTF, then the value for the 3 years 42, 43, this is forecasted value. 42, 43, and 44 will be displayed here. Work file will display in the work file the 42nd value, 43rd value, 44th value will be displayed in the MS Excel. And you can also check if our forecasted value is correct or not. How we can check the forecasted value is correct or not? You check with the view, and there is a possibilities of ARMA structure. I am not sure, right? 1 second, not here. View. Okay. Forecast check. 1 second. I have. Not this one. Okay, and one more thing, that is actually we have arrived the forecasted value, and how I will check it. And there is a no, not this one. Okay. No, that's all. I think so. Okay. Forecast evaluation you cannot find. You cannot find the forecast evaluation. There is actually serious in MS Excel, correct? And we can know that there is a possibility of check ARMA structure. I just want to see ARMA structure. Where is it? 1 second. View ARMA structure. Here also not there. No. Object properties. I will check 1 second. Okay, anyway, I will check and tell you where the ARMA structure is located, because the model that ARIMA model is that's all. But anyway, that there is one method where we can check the forecast checking for checking on ARMA structure, ARMA. For that we can able to find out the result whether it is a correct or not. Okay. Yeah. Once again, I am explaining you. I will delete all the things and I will explain once again. For somebody has asked about. Please note out. First, we want to go with the software. Then click ARIMA file. Then put it into calculation. Then what we want to do, first one, there are 2-3 datas, wheat, TFG, and rice. We are going to, I assume that we are going to find out the forecast value for wheat. If you done the wheat analysis, how many datas up to 2010-11, right? This is the data. You just copy it. Okay, you just copy it and paste it in separate Excel format. You can Excel format, you can, or otherwise we have it. No, Excel, new Excel. One second. So this is the wheat data. Okay, we understood that this is the wheat data. up to 2010 and 11. So we have totally 41 observation. So we have only 41. Excluding this one heading, we have 41 observation. We want to know about 11, 12, 12, 13, 13, 14. So in case, how we want to calculate the forecast? So simply go to view eView software, open an existing data file. So Arima, there is a one data set in the name of Arima. Click next, 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 then finish. Assume that we are going to forecast the value of wheat. So what we want to do, we want to open wheat. Just a second, there is some process is going on. Once again, I am explaining. There is some slow process in my laptop. 1 second. I am sharing my screen again. Can you able to see my screen?
Yes, okay.
Okay.
Yes, sir.
Yeah.
Yes,
Click
sir.
Arima file. Click next, 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 finish. As I told you already, I am just estimating the wheat forecast. Okay, wheat value forecast for the next 3 years. So what I want to do, first I am going with the open the wheat. This is the value of the wheat. I am going to show you Carlogram, and when with I am going with the level first 0th level, you cannot estimate the spike over. Okay, significant spikes you can find only in AC, partial correlation, and only one PACF at lag 1. And it is actually, this data is a non-stationary. Data is non-stationary. And if we want to check again with the unit root test, it is also possible in 0th level whether it is a stationary. No, the probability value is higher than 0.05, so it is non-stationary. So what we want to do again, so we want to go for calculate the first difference. So Carlogram first difference level, okay, then it has come here. Then this is a lag. This is a lag 1, 2, 3, 10. So up to 20 lag is there. So 10th lag, the PC partial PACF value will come one spike after this lag 1. So this is AR1 and AR1, and this called as a partial correlation is called as an MA 10. Assume that it is MA 10, 10th lag. So if you want to check the unit root, also possible. We can check with the first difference unit root. You may find that probability is 0, 0, 0. So it is less than 0.05. Even in the Carlogram value also, you find that MA is 10th lag. Okay, AR1 and MA, we fix that AR1 model and MA10 model, AR1 and MA10 model. Then we want to check that we want to check that this file work file, then go to select wheat work file, then go to procure process. That then we have to go for structure or resize, then select unstructured or unstated, then include 44 variations, 44 observations, 44 observation, then make it as change, okay. Then next step, we are going to estimate the ARIMA. So here what we want to do, so if you want to click wheat, you can find that, there is a 44 observation. So next step, what we want to do, we want to estimate the equation. And for estimate the equation, you can go to quick, there is an option called estimate equation. Here you can write difference of wheat, then space C, space AR1. Why AR1? I have told you. One spike at one spike at AC, and one 10th lag spike at PACF. And D of wheat, C constant, space AR1, space MA10. Then click OK. Okay, click OK. You will find this value. And here I will show you the value at later. Here there is one more option from the output view. There is a structure, ARMA structure. Roots, you choose roots, grab and click OK. You check here. All the values are inside the structure of polynomial, inverse roots of polynomial. Then we have decided that ARMA model is perfectly good. This is AR root and this is MA root, AR1 and MA10. So whatever we have chosen, this model is perfectly fit. Okay, perfectly fit. Again, I am telling that this is ARM structure. Then if you want table format, that also you can do it. Okay, table format also you can do it for interpretation, or we can do it as a graph format. So what again we want to do from the output window, then we can forecast. This is the level wheat F. Okay, wheat forecaster. F means new name, forecaster, wheat forecaster. Select dynamic forecast method, graph forecast method, or any method, forecast and actual. That also possible. Okay, forecasted also, or forecast with the actual. If you want forecast with the actual, that different diagram will be displayed. Then click OK. Okay, now it is not possible. Only we can do it forecast value. Okay, so forecast, only forecast. Click OK. Once again, I'm not sure. Forecast. Forecast level, forecast, correct. Dynamic method. Okay, I unable to complete. 1 second. Once again, I am writing. What I should do, like okay, then I will go for quick estimate equation. I will write D. I'm not sure why it is some problem. wheat CAR1 and MA10. Then click OK. So the value will come. We can check, already we check ARMA structure. That's what I have removed. Now I am not ready to go for ARMA structure. Directly I am going for forecast. And then click OK. Unable to compute due to missing data. We have done actually, all data we have done. I'm not sure. Forecast, last time it came, now it is not. I'm not sure why it is not come. VTF level forecast and static forecast. Okay. Maybe there is some mistake in some other data. I'm not sure. Anyway, I will check it once again. Open foreign data is a work file. There are some data is missing. Okay. Arima. Okay. Now we directly go to this. I think wheat is there. Wheat data. We go carlogram, etc., etc. We have identified. Assume that we have identified. Okay, we have decided that. Then we decided Arima structure. Okay. Then we directly go to work file. Structure, we can change the structure to unstructured, then 44. Then click OK. Okay. Carlogram. Okay. Okay. Okay, right. Then we can, now we do with the quick estimation. Quick estimate equation. D wheat CAR1 MA10. Then click OK. Again, we are going to forecast. Forecast. Click OK. Yeah, it is coming. Now it is coming. I think some data missing on the previous file. Now forecasted figure is coming. Forecasted figure is coming. Right? In forecast, if you want to go with the only forecast and actual, that is also possible. So this is forecast and actuals. Okay, forecast one, actuals one. Then come to, if you want to see that, obtain the forecast level, again you can close it here. Close the file. Then you can see the forecasted value file once again. Wheat forecasted. This is a forecasted value. So you can copy this one. This is actual data file. This is actual data file. Assume that I am going to insert, right? This is third 42nd 40. This is the value. This is the value. You can copy it. copy as displayed. Okay. Then copy it here. Okay. This is a third 3 years data will be forecasted. 3 years data will be forecasted. So this is a method of forecasted ARIMA approach. This is a method of forecasting ARIMA approach. Okay. So any quick questions if you have in your mind, please ask. Otherwise, we will go for next one. Any quick questions? Okay. Okay. Now I can explain you a small VAR model. Okay, vector auto-regressive model. Vector auto-regressive model. Vector auto-regressive model. What I should do? Vector auto-regressive model. VAR. Please understand VAR model. I will close all the things. Open workshop material, data file, where model. I just check with Excel if anything. Yeah, okay, fine, perfectly fine. So data on income is Y and money supply is M. Interest rate of interest is R. YMR. Income, money supply, rate of interest. I want to do the vector auto-regressive model. Vector auto-regressive model. Before going to that, what is VAR model? Okay. What is VAR model? I will explain you. So actually it is a vector auto-regression model is to study the relationship of different model, different quantities. Yes, they change over time. Okay, where is the model to use to capture the relationship between multiple quantities as they change over time? Okay, while it is widely used as a time series to examine the dynamic relationship that exists between variables, how one variables is intersect with another one variables, how one variable is interact with another variables. Here in the data set I have clearly told you income, money supply and interest rate, how each other are interact with one. So that's why we are going to see in the auto-regressive model. I'm sorry, I have stopped to screen. Entire screen share. Please listen, all of you. So this is a data set. I have told you Y is an income, M is a money supply, R is an interest rate. R is an interest rate. Then I should open a. I can open a eView software. Go to file, foreign, open as a foreign data existing file, desktop. Then I will open where vector auto-regressive model. I will open here, click next, finish. Click yes. Now what we want to do, first one, we want to transform M, Y and R in log and convert LM or LY or LO respectively. What we want to do, first one, we want to go for generate, enter equation LM is equal to log of M. Click OK. Then again go to generate LY. is equal to not here, log y, ly is equal to log of y. Again, I'm going repeatedly very slow. Generate. Again, I'm going to transform one more data, interest. LR, logarithm R, is equal to log of R. Then click OK. Oh, what happened? I'm sorry. LR is equal to log of R. So LM, LR, LY all are created. Okay, logarithm value LM is created, LR is created, interest rate, income is also created. Okay. Now we want to create ADF. You just check LM, right? LM. So what is LM? Again, I am telling you. If you want, I will tell you again. Y means income, M means money supply, R means interest rate. Okay. So money supply, what I should do? I will go for view, unit to test, level, it is not come. Again, I go unit to test, standard test, first difference, it come. Again, it is 0 less than 0.005, 0.05. Similarly for LR also, if I check with the level 1, it is not arrived. It is not less than 0.05, 0.05. It is 0.4. It is not less than, it is higher. So we go for first difference. Okay. Yes. Now it is less than. Again, similarly for LY. First difference level, 0th level, no, it is 1. It is very high. So that's what we go for. First level difference, yes, it is probability. The probability value is less than 0.05. So according to ADF unit root, in the first difference level, all series are stationary. Okay. So which means to estimate where model, to estimate var model, we shall use to first difference. We shall use first difference. What we want to do now, we want to estimate the var model. We want to estimate the var model. What we want to do first? We want to go for quick, and there is a one option called estimate var. Estimate var. Select estimate var and select standard var. Select standard var and in indigenous variable box write difference of LM space difference of LY space difference of LR. Please write out. Okay. Quick, go to quick, estimate var, select standard var, write in endogenous variable degree of difference of LM, difference of LY, difference of LR in endogenous variable box, and write lag 1. 1th model in first order level. If second order level, if it is difference, then write lag 1 and 2. Here 1. So 1, 1 in the log intervals. So because it is one period is lag, then lag 1. I already told you to estimate the where model, because the ADF unit root is stationary in the first difference level. So that's what we have taken the one level lag. So click OK. Click OK. You may find this is the output result of where I explain you. One second. I explain you with the one second. Okay, I am writing here. Please note out. Okay. Here, higher growth of income. Higher growth of income. That is, higher growth of income means dy. Higher growth of income, DLY leads to higher growth of money supply. DLY leads to higher growth of money supply. Here you can check here, this one constant. Okay, money supply of DM, that is D of LM in period T, in period T, time period, T statistic, right? Time period. The same relation holds, the same relation, you can find the same relation holds between growth of interest rate and growth of money supply. So this value here, growth of money supply and growth of interest rate. See, that is, if you want, you can write out in the bracket so that you can easily understand. 1.80610. Okay. How to test this is the value. So with this is a where model. We can also use the where model to test the Granger causality. Okay, Granger causality. Okay, Granger causality. What I should do? You can go to view. There is a from the output, please. Okay, that's all about where model, where estimation model. From the where estimation model, we can test the Granger causality in where. We can test the Granger causality in where. How we can test the Granger causality? From the output of vector regression estimation, you can go to view log lag structure, and there is a one method called Granger causality and blocks exonerity test. You click this one, it is automatically the result will come. The result will come. So here, what do we want to write? Similarly, I will tell you from the result how we want to write the interpretation. See, first one, this is related to money supply growth. Money supply growth. Then second one is a income growth. Then third one is a interest rate growth. Interest rate growth. So here it is from this result, different variable DLM, DLY, DLR. I am going to tell you only one, money supply growth. So which means you can write DLY leads to DLM will decide on DLY. That is Granger causes DLM. Similarly, this is one DLM causes DLR. DLR Granger causes DLM. Similarly, DLY, you can follow it. You can follow the even after after our presentation. I can also upload the video. You can understand easily. D of LY, D of LR, which leads to D of LM, all focuses on D of LY and D of LR. Jointly, Granger causes on D of LM. Money supply alone, I have told you. Similarly, you want to write the formula for income growth and interest rate growth. Similarly, you want to write income growth and interest rate growth. You can write the interest rate growth and interest growth. Okay. So this is the Granger causality equation in where. So you can start with the even where we have perfectly identified the where model, vector autoregressive model. Then using the where model, we also test the Granger causality. Okay, to test the Granger causality. And I just want to tell you how the Granger causality is useful. Okay, how the Granger causality and where model is useful in estimating where model. Okay, how the usefulness of the estimated where model is useful. So here, what I should do, there are different methods. Sir, any doubt so far? I will proceed. Shall I proceed, sir?
Yes, please proceed, sir.
Yes, sir. Actually, now I just want to tell you what are all the usefulness in the estimated where model. estimated where model. First one, go to view, then there is a column called lag structure. Select lag structure, then select AR root table. Okay, you may find this is the explanation for the where model. Or you can go to lag structure AR roots graph. From this also you can able to how the AR characteristics model is useful. So here we what we are going to conclude, where that is vector autoregressive model satisfy the stability condition. It stability, so you can see that this is the outline. You can see that this is the out inside the circle, the inverse roots of AR characteristics is lying. So we decided that it is a stability condition. We can also go for lag length selection. So go to view, again go to view, there is a lag structure, then there is a lag length, lag structure, lag length criteria. You can specify the lag as 3 as usual, you leave it and click OK. So these are all the some usefulness of estimated where. Okay, how estimated where is suitable. So inverse roots of AR characteristics polynomial in table, we have to know from this different analysis. It's not an analysis, we are checking the estimated where model. Okay, you are checking the estimated where model. So it appears that value AC, SC. So AAC means Akachi information criteria. In unit root, I have explained one method, and is Chicago's information criteria method. A is HQ Hanum human information criteria. These are all three methods for measuring ADF unit root analysis. So in this method, it appears all the values AAC, SIC, and HO are all minimum possible lag. Minimum possible lag. Within 3 lag, it all fulfills. So again, where is suitable. Or we can also check with the auto correlation LM test. Auto correlation LM test, that is possible presence of auto correlation, whether it is available in the where model or not. Possible presence of auto correlation in where model can be known from view, residual test. Then there is a one method called auto correlation LM method. Specify at least 6 lag and click OK. It will display here. Then we can also check the impulse response. View impulse response, and it defines impulse response. Yes. Okay, same analytic, right? Okay, it click OK. Yes, this is all impulse response method. It defines long run equilibrium of the model. And finally, there is only one, various T composition model, variance decomposition model. I mean the proportion of the forecast error variance of variable which is explained by an unanticipated changes. So how we can know, we can go to view again. Here it is a variables, right? Variables and various compositions. To know proportion of the forecast error variance of the variable, decomposition. Here I have explained you the same manner for output views, table, right? Multiple graph, combined graph. like a table, multiple graph, and combined graph. Everything is displayed here. So there are 5 methods of usefulness of estimated WAR model. One is inverse root, log length selection, auto correlation LM test, impulse response, and variance decomposition test. Variance decomposition test. So here we know that from the table or in the graph, so how we have to go to view variance decomposition, and you can provide the period 20. Click OK. See here how we can write. Even 78% or more of forecast error. Okay. 78% or more forecast error variance is accounted for my own shock even in the 20th year. So that is a conclusion. 78% variation in the forecast error, even after giving more shock and even in the 20th year. So that's what period I have given, 20th. Okay. So this is a conclusion. So my dear friends, so once again I am explaining you not all the steps. For only calculation of WAR model I will explain you. Okay. WAR model I am explaining you. WAR model I am explaining you for your benefit. Yes, just a second. Next, finish. Then we want to create equation. Generate LM is equal to log of M. Then generate Ly is equal to log of Y. Ly is equal to log of Y. Again, Lr is equal to log of R. We assume that all the Lr, Lm, Ly has arrived first difference level stationary. Okay, then what we want to do, we want to estimate the WAR model. For estimate the WAR model, we can go for quick estimate WAR. Estimate WAR, and in the indigenous variable, you write DLM, then difference of DLY, then difference of LR. Then here you can write 1, flag 1. Then click click OK. You will get the result. You will get the result. So then I have explained you this based on this interpretation. I have explained you Granger casualty in where? Granger casualty in where? So the Granger casualty, I have explained you the casualty between three endogenous variables, how we can find out money supply growth, income growth, and interest rate growth. So we conclude that both the casualty test and where estimation result is same. Okay. After identifying the Granger casualty test, simply, so Granger casualty is simple. You just go to view. You just go to view lag structure. Where is it? Lag structure. Yes, lag structure. From the lag structure, there is a one option called Granger casualty. Click Granger casualty, and we find the result. Both the casualty test and where estimation result are same. Okay, where estimation list and Granger casualty test results are same. Then I have explained you to check the usefulness of estimated where model using inverse rate of AR model, lag length selection model, auto correlation model, impulse response model, variance decomposition model. We can check the estimated where model. Okay. So this one is a where and Granger casualty. After using this model, we can check whether the where model is correct or wrong with the help of the different method. One is lag structure identification, lag length selection, auto correlation LM, impulse response, variance decomposition model, right? Variance composition, decomposition model. So I maybe 5 to 10 minutes break. 5 to 10 minutes break. If meantime, if you have any queries, you can ask. 5 minutes, 5 minutes to 10 minutes break. We will exactly by 3:30. We will continue for arch and Karch model. Arch and Karch model. If you have any queries, please ask.
Sir? Hello? Sir?
Yes, sir. Please go ahead, sir. Please ask a question.
What are the objectives of the each and every model, sir, in addition to OLS model? The VAR model, AR model, and the model.
What are all?
What are the objective of the each model in addition to OLS model? OLS model is enough or not enough in the explain to the secondary data. Then what are the reason for further models, please?
Yeah, all the models are used for studying the relationship, studying the forecast, and to know about the data validity. For that only we are using the different models. See, in time series analysis, there are so many models are available. But we want to know when we are doing a research, we want to know, say example, I am telling that suppose I want to forecast, then I may go for ARIMA model. Then I want to study the how the data is validity, then I will go for normality test and descriptive statistics. Then if I want to know about the long run relationship and short run relationship, then I want to go for vector autoregressive model or Granger casualty model. There is one more model called Johansson co-integration model. And if I want to study the casualty between the two variables, then I will go for Granger casualty model. If I want to know the volatility, say example, in the stock market, you find that there is a huge volatility for last 1 year or 2 year. how to test the volatility, then I will go for arch model, arch effect, Karch model, etc. So likewise, each and every model, there are certain objectives, and accordingly we want to go for to choose the test. We say based on the objective of your research, writing a research article, you want to apply the following test. It is not necessary to use all the tests, but the common tests are descriptive statistics, normality, unit root. Unit root is always required for doing any research because it is a basic. So you want to perform first, you make it as a stationary data as a stationary, then only you can perform the different tests. Hope you understand, sir.
Okay, sir. Thank you.
Shall we proceed, sir?
Yes,
Shall we
sir.
proceed? Everybody is
Yes,
ready?
sir.
Oh, yeah, fine,
Okay,
fine.
sir.
Yeah. Now, with a short break, I take you to first we can going to learn on arch, then we learn on Karch model. Then I will show you some of the research paper where we use different types of econometrics approaches. Okay. And after that, I will take some question and answer. Then we will wind up the session, right? Okay. And there are two approaches. One is a arch effect, another one is a Karch effect. Okay, one is a arch effect, another one is a Karch effect. And what is arch? Actually, arch means ARCH. I will tell you ARCH. ARCH. I'm sorry. ARCH. Arch means it is actually the two important model we called as a volatility model. These two models are also.
Screen is not visible, sir.
No. I have not yet shared. The arch model and another one is a Karch model. Both are called as a volatility model. Okay, arch and Karch both are volatility model. Both are volatility model. Arch full form is, I'll tell you, arch. So just a second. Auto regressive conditional heterozygosity. This is the full form of arch. Auto-regressive conditional heterozygosity. It is a full form of arch. And Karch means generalized autoregressive conditional heterozygosity. Karch. Okay. Both are volatility model. So it is a statistical model used to analyze volatility in time series in order to forecast future volatility. Okay, in order to forecast the future volatility of the time series model, we are using both arch model and Karch model. I hope now, yes. I am sharing the screen. I go with the times, times e-views analysis. Then click foreign data as a work file. There is a one file named arch model, arch and Karch model in the workshop material. Yeah, this one, arch and Karch model. You click next. Actually, this is a stock price movement. This is a Toronto Stock Exchange movement. This is a stock exchange movement. Toronto Stock Exchange movement. Yes, volatility model, correct. Volatility model. This is a Toronto Stock Exchange sense point, just like a Sensex India, Toronto Stock Exchange point. Then what I should do? First one, I should do. I am having some queries. Okay, thank you. What I should do? We can go for view, graph. Okay, you may find that there is a volatility. There is a volatility in the chart. Okay, there is upward movement, there is a small, right? Again, it is upward, downward. That may be a volatility in the model. So what we want to do, we can go with the volatility estimate arch model. We want to go more, we estimate AR1 model first. Okay, we want to go for estimate the arch effect in the Toronto Stock Exchange Index. We estimate AR1 model, AR1 model, right? You need to test. Yes, it is high. Now it is stationary. And if you take example parallelogram also in first difference, yes, fine. Okay, it is one model, AR1 model. It is AR1 model. Here also one, here also one. It is, we decided that it is AR1 model. Then what do I want to do? Go to quick estimate equation, then write an equation like TSX is a point, Toronto Stock Exchange, TSX, then constant, and TSX minus 1. This is volatility model. Okay, minus 1. Then click, minus 1 is a one model. Click OK. You will find the result, arch effect. Minus 1 is a residual, right? Minus 1 is a residual. So now you perform arch effect in residuance of the estimated AR1. This is an estimated model, estimated AR1 model. AR1 model. What we want to do, first view, go to residual diagnostic. Here you will get heterosidosity test. Then from the heterosidosity test, number arch effect, you choose arch effect, then number of lag is 1. Number of lag is 1. Yes. Then click OK. It appears TF statistic, that is TR statistics. Probability values, chi-square value, everything is 0.00. That is p value is less than 0.00 here also. So we reject the null hypothesis of homozygosity. We reject null hypothesis of the homozygosity, and we conclude that arch1 model, okay, here it is reject the null hypothesis. We conclude that arch1 effects are present in the series of TSX. Arch1 is present in the effects is present in the TSX series. I will once again explain you. What are the steps we are done. Just a second. You go to file, open foreign data as a work file, then click the data set. Next, finish. Click yes. From that, you know that this is a value DSX. You can go to graph. You can check the graph also. You can also check with the unit root. In first order, it is 0. It is first order is 0. Then we are going to estimate the equation. Estimate equation. We write TSX C intercept, then TSX minus 1. Then click OK. You will get this value TSX minus 1. Now you can perform arch effect in residual model with estimated AR1 model. So for that you can go view, then residual diagnostic, click heteroscedasticity test, then click arch test, provide 1 lakh, then click OK, and p value is less than 0.5. Okay, see here it is observed value plus r square value. This is observed value and r square value. Observed values and r square value. Heteroscedasticity test arch, heteroscedasticity test arch, observed value and r square value is given, and the probability chi square value, the probability f test value, residuals value, everything is less than 0.05. See, even f statistics probability also 0.05, less than 0.05. We conclude that we reject the null hypothesis. We conclude that we reject the null hypothesis. That means that there is a homozygosity, and it conclude that arch1 effect are present in the series of Toronto Stock Exchange. So this is the arch model, very simple model. There are a lot more analyses, AR1, AR2, arch1, arch2. So many tests are there. You can slightly learn one by one, because we cannot teach all the tests simultaneously. It is not possible in the 6-hour duration.
Sir,
I just gave, yes, ma'am.
sir, I have a doubt. Sir, what will be the null hypothesis for this arch model, sir?
There is, that's what I told you. There is no arch effect. There is no arch effect, volatility effect.
Okay.
And we conclude that p-value is less than 0.05. So we reject null hypothesis.
Okay, sir.
And there is a arch effect. There is a volatility is available in the TSX.
Okay, sir. Thanks.
Volatility is available in the TSX.
Okay, sir. Thank you, sir.
Okay. Okay. And second one is a Karch model. Karch model. Yes, Dinesh sir, I will tell you. Don't worry. We can select ARIMA and Arch model. Arch model is volatility, and ARIMA is forecasting. I have told you, right? ARIMA is a
Sir, there is no audio.
ma'am. Sorry, I'll go. Okay. Next test. It is a Karch model, generalized auto-regressive conditional heteroscedasticity. Next one is
Sir, sorry to interrupt. Before this, can I ask one doubt, sir?
yes, ma'am.
Sir, like when we do the stationarity test or any residual, I mean diagnostics text when you do, when we run the test and if the p-value is not significant, then we go for the either we try to convert the data into log or maybe we take the first difference. Am I right, sir?
Okay.
So when we take log, we write log off. I mean, within the bracket, or if it is difference, we write D and within the bracket, we write this. Suppose if both are not satisfied and if we go to second difference, how do we write the equation?
That is a difference of D. Okay, I will tell you. I will tell you. 1 second.
Yes, sir.
Very good question. I will show you that. Just a second.
Ha, sir.
I will show the important. One second. Yeah, this is the first order difference formula. This is the first order difference formula. And this is the second order difference formula. Okay, second order difference formula. Okay, and you are asking, ma'am, you are asking, can you repeat once again?
Sir, what I asked you is when we write estimate equation in the EVOs, for first difference we write D and then we write that variable. For second difference, how do we write?
You told me, ma'am. One second, ma'am. For that is you to, dx minus 2, ma'am. Hello. Yeah. One second.
Yes, sir.
Ma'am, I have put as here.
Okay, sir.
I have put in the chat window.
Okay, I saw. D of x comma 2 is what we'll write, is it?
Correct.
So here x refers to the variable, like,
Correct.
like you have written
Correct.
ly or consumption or whatever.
Exactly.
Okay. So comma 2 if I we write, so that is second order, huh?
Yes.
Oh,
Exactly.
okay. Got it, sir. Thank you so much.
Okay. Coming to that, I'm sorry. One second. So actually, this is the formula. I told you already, in writing a research paper and all, we always write to the formulas. This is the first order difference and second order difference, right? First order difference and second order difference. Once again. Again, we are going for E-views. On the same data set, we are going to, that is TSX data set, we are going to estimate the Koch model. Okay, we are going to estimate the Koch model. What we want to do, you just go to Koch model, you just click, yes, everything is fine. Now go to quick estimate equation. Here in the method, you choose arch autoregressive conditional heterozygosity. Okay, estimate equation. Okay, once again I am explaining you. Quick estimate equation. In the estimation settings method, you can choose arch autoregressive conditional heterozygosity. Then it will open this type of window. Here you can write equation estimation. Okay, here you can write equation estimation. Koch 1, I think, right. TSX constant TSX minus 1. Okay, in the mean equation, and write one for arch 1 effect and arch 1 effect. You leave it again, you leave it RCM, it is not required. Okay, so only thing is you want to write TSX C TXX minus 1, and this is arch or torch something. Here you like arch 1 effect, arch 1 effect. Method you already choose, autoregressive conditional heteroscedasticity, and click OK. Yes, it is displayed here. P value, TSX P value is 0.000. So this indicates presence of volatility clustering. This indicates the presence of volatility clustering in the series of Toronto Stock Exchange. So here, if you check here, the Karch 1 effect, 0.789815. Okay, and residual lagged square value is 0.18617. Coefficient lagged squared residual. This means coefficient lagged squared residual is 0.186172, and lagged conditional variance, this one 0.789815. So it are both very close, positive. So it is unity, which implies that there is a volatility shocks, 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 volatility shocks, high volatility in the Toronto Stock Exchange series, and it is persistent in the particular data. We conclude that there is a huge volatility in the model, Karch 1.1 model. Okay, Karch 1.1 model. There are so many other types. T-Karch is there. Okay, so many. See, if you look on that even quick window estimate equation, they will ask so many types. Here arch model, here model, so many types. E-Karch is there, Parch is there, component arch 1, F-Karch, Karch, so many models are there, but we just learn only arch model and Karch model, right? And I will, okay, this is for, we have already done. I will show you some research papers in the areas, I'm not sure, one second. Yeah, this one. This is a journal called Econometrics, how we can write the paper. Okay, it is, I will share it, this material. You can use, right? You can use for, this is one way you can write the paper format. And there are, how we can write the economic research paper. This is one this one is there. I will show that. I'm sorry. This is the model where we want to write all econometric research paper, finance research paper, and empirical economics research paper. We should follow this format: introduction, literature review, theoretical analysis, and empirical analysis, conclusion, references. I will show you some of that. See, this is the one research title. Okay, I have make it as this format: relationship between money output and price level in India, Granger causality approach. And these are all the some objective format. We want to build a theory, and very important why the study is important. See, 1 second. Yes. This is the one important data description. This is related to FIA. Discover the relationship between FIA. I am sorry. How much time? What is the final slide I have gave? Can anybody please tell me? My connection was lost. Can somebody please tell me what is the last
Sir,
slide?
you were telling about paper writing.
Okay, fine. Okay, okay. Right, sir. Right, madam. I think I have shown this slide, correct? All the up to results part I have shown, correct?
No, sir. Sir, your screen is not visible.
This one I have shown you, correct?
Sir, you didn't present the screen, sir.
Sir, your screen.
I'm
Sir,
sorry.
your screen is not
I'm
visible.
sorry. I'm sorry. Can you able to see the screen?
Yes, sir.
This slide, I think I have presented. Okay, data description, data source, and we want to write the result of ADF test, different test. Then,
No, sir. No. No, sir.
what I mean?
Before.
Okay, thank you. So this is an ADF test of the different test we have carried out, and for the dependent variable alone, we have draw the diagram. And these are all the different methods of stationary test unit root analysis, and interpreted the result in the table so that the reviewer may know that the researcher has applied the different interpretation on the unit root test. Then come to this is the way Johansson co-integration test, how we want to perform. So I have not discussed Johansson co-integration because we have some other test I have performed co-integration. That is on Krangwer causality test we have performed bro. And how HO is futures that does not cause spot market. Future does not cause spot market. And future causes spot market is a H1. Okay. Future causes spot market is a H1. And we identify the result and analysis the different values and come to, okay, I will tell you. This is the paper we have written and published in the very good journal. I am not shown you, I am not know whether it is downloadable or not. I think it is downloadable. Can you able to see the screen?
Yes, sir.
Yeah, perfectly.
Yes,
Right,
sir.
this is a co-integration on the stock market interdependence. Evidence from South Africa, India, and the USA. So we have published one research article. It is a South African Journal of Economics and Management, right? And this is the abstract format. Then we have applied an introduction, right? Applied introduction part. We have literature. We have written literature review. Then methodology. We have told about research gap, questions, what nature of associations exist from the stock market movements of India, South Africa, and US, and how are the stock markets indices are related to other in long and short term. There is a relationship. Okay, so research questions is nothing but objectives. Research questions is nothing but objectives. Are any stock market indices among the South Africa, Indian, American markets useful for forecasting? That we have applied some test, right? Here we have used for India, National Stock Exchange, NSE, NASDAQ is American Stock Exchange, and South Africa, Johannesburg Stock Exchange. We have done for normality test, unit root. Then we have also done for linear correlation, Krangwer causality, co-integration approach, vector autoregressive model. So these are all the descriptive statistics result, mean, median, mode, etc. These are all the some examples on the descriptive statistics graph.
Sir, this is what is the duration, sir? How many years data you have taken?
Madam, I will tell you, ma'am. I will tell you. I will clearly mention in the methodology part. See, methodology part. It may be varies, ma'am. It may be varies. See here, we have applied. Okay, we have applied the data from April 2004 to March 2015. Almost 10 years data we have applied. Okay,
So is it annual or monthly or daily data, sir?
Maybe it is a daily data, no? Stock exchange index is daily data. Okay. So this is a close value. I have clearly explained about natural log of monthly close price. We have intimated the monthly. It is up to you. You can choose monthly. You can choose you can clearly mention in here we have used monthly close price. So monthly closing index value will be calculated. You can also take daily. It is up to you. Okay. Yes, ma'am.
Yes, sir. I mean, the paper looks very interesting, and
Yeah. You
if
need
you
to
can
link.
share this, we will
Yeah,
also
definitely.
refer,
Definitely.
and maybe we can also cite when we do our.
Yeah. It is actually it is a very old paper, 7 years old paper. We have published in 2015. Very basic, but very simple, very simple. And this is three indexes, and these are all the ADF test result are at level. What is the value at first order level? What is the value? So I came to know that all the values are fulfilled in the first order level difference. Like that, we want to write. And this is correlation matrix we have done. So correlation analysis also can be performed. Then where, what is the result? I told you AACSC, the final table I have shown you, where lag order. Then where Granger causality also I have explained you. This one. Johansson co-integration I have not discussed it today. This is a vector autoregressive model. You have to project the result of the vector autoregressive model. You can usually download. I will share the index here. You can easily download. You can easily download this paper. Okay. And one more paper. There are so many papers we have written in econometrics, and mostly we have published in very good quality journal. And there is a yes, this is also good paper. Foreign direct investment and economic growth. See, foreign direct investment and economic growth. See here, this is also in a Scopus index. How this is, we talk about FDI and GDP. FDI and GDP, we talk with the linear correlation unit root. Same model, but the different format. Same model, right? The same model we have applied where everything. Very basic paper, but it is some fruitful result. Other format. You can also download this paper from this link. Okay. Then some more paper I will show you one by one. This is FII flows and Indian equity market performance. Again, it is also available in the ResearchGate. FII flow. Here we have this is an objectives and the relationship we have applied, right? We have applied very simple tools only we have applied here. Then oh sorry, I have closed it. This is study on comparative analysis of risk and return, analyzing the impact of CNX Nifty future and volatility. Here we have applied card charts and all. Okay, this is the paper published in the Journal of Indian Journal of Research in Capital Markets, Indian Citation Index journals. So here it is not a Scopus journal, but it is running by his Indian Journal of Marketing and Indian Journal of Finance team. Okay. So where we have applied the different tests and the different review of literature format we have applied. We have applied these descriptive statistics, Jarkubara test result, stationarity test. Okay, this is a trend. If at all intercept, how we can interpret in trend and intercept. If no trend and intercept, this is a formula. Serial correlation and Bruch-Colby LM test, heterozygosity, Carlogram, Garch model we have applied. I told you. Then this is a result of this paper, stationarity. Then residual analysis, we gone for serial correlation. Then we gone for arch effect. Then we also gone for our Karch-Unknown effect. So this is a Karch-Unknown effect model. This is a Karch-Unknown auto-regress correlation heterozygosity. So there is no arch effect, there is a arch effect, and we found the result. So very compared with all other quantitative research, I mean in primary database research, we can easily write the research paper in finance and economics. There are a lot of journals are available that, but the thing is that we want to learn every day the new tools, because it is only an eye-opening session where you have to learn a lot more tools. I just explain only the basic tools. I also don't know the very vast and other complexity tools where we apply in the econometrics. It is every day we have to learn so many workshops you can attend so that you can easily learn. This is related to forecasting foreign institutional investors investment flow. It is actually an ARIMA type of research paper. You may not easily download. I can check it. Yes, you cannot download the paper. Okay. They are asking about, actually it is not a open access journal. Foreign institutional investment and stock market returns. That I will show you. This is projected time period, Crank causality, impulse response that I told no, variance composition, impulse response, normality, correlation. This is impulse response, and we have applied the result also. Okay. So many articles are there. I will show, I think I have already given my Google Scholar link. You can refer, if you refer my Google Scholar, you can get so many papers. This is my Google Scholar link. I can also show you the ResearchGate link. This is my ResearchGate link where you can access so many research papers. If you have any doubts, I will close the session. I will close the session. I hope I can also expect some open feedback from you all. And if you have any specific clarification and doubt, always welcome to ask. Yes,
Hello,
sir.
sir. I don't have doubt, but I ask one request. Like, if you can provide us a link or different database from where we can download the data, which is not mostly available for free, and this is a big constraint for secondary data, sir.
Correct, exactly, sir. I will tell you, sir. I will share it also. You can send a personal request to me. I will share some of the data files, right? Data repositories. Even if from the eViews itself, you can use eView software itself. See, you can see eView software download, free download. Here you will get lot of soft data sets. Here you can get data sets. After download, you will get lot of data sets are available.
Sir, can you share your screen and show that to us?
Sorry. I'm sorry. See, there are some material I have got from the even eViews itself, right? eView, 1 second. Yeah. Correct. So this is a learning resources are available. When at the time when you receive the serial number, you will get some links. Okay, from the link you can also get learning resources and tutorial. From the tutorial, if you click the tutorial, you will get a lot the data set here. Sir, excuse me, sir. You can get this data set from here.
Uh-huh. Yes.
Okay,
Okay.
all the data sets, all basic data sets. Mostly I have covered, actually I have prepared the brochure based on the eViews basic. Okay, eViews basic. Mostly I have covered all the analysis. But the data set I have applied a different. Okay, I have not applied the data set from this data, but you can use similar data sets.
Sir,
I
this is dummy data or the real data?
I hope it is a real data. Okay, I hope it is a real data. I will show you that these are all tutorial, right? Time series data. So each one have done some data. See here, it is data is there. Sorry. If you need real data, then you should take from the websites of RBI, moneycontrol.com, NSE, or you can also get from other stock exchange. These are all some data, some real data, some data which can be used for prepare. I am not give the guarantee for it is a real data. So if you, but for writing a research paper and doing a research, we need a real data. Correct?
Correct. Correct.
Exactly. So it is only for practice purpose. So you
Sir,
can
there is
go.
one more problem, sir. You
Yeah.
know, sometimes we are not able to find out from where we can get the data, means exact location or organization or agency who actually
Exactly.
publish that.
Exactly.
So, like for example, financial inclusion.
Hmm.
Uh,
Sir,
and
actually, there is
yeah,
a one platform called ProVes. Hope you know that.
ProQuest.
Yeah,
Yes.
ProVes. It is actually CMIE database, Center for Monitoring Indian Economy. CMIE database. It is a paid version. Our institution is subscribing this database where you have to get almost 60,000 corporates full details. CMIE database, right? CMI
E. Okay.
database. Okay. This is a CMI ProVes. CMI ProVes. This is a ProVes IQ, right? So
Okay.
you will get a lot of information. See, check here database of business entities, business, economics, all information you will display here. But
So it will
actually,
be.
it is not a what I say. It is not a free database. It is paid software. Almost yearly, we want to look. If we want to go for complete data access, I'll give maybe like 4 lakh or 5 lakh. But only for company access, it may be like 1,50,000 to 2 lakh.
Okay, so it also have like free or trial classes or something here, free data for 15 days, 16 days. It is like this
No,
available.
no.
Do we need to purchase directly?
Yes, yes, yes. I
Okay,
think you are some most of the institution in India they have subscribed this database.
okay. What
You
about sir international data?
Yeah, international data. We want to only thing is that we want to browse in internet. There are so many channels are available
But
nowadays.
what the most authentic was, sir? The problem is that some research papers show normality stationary
Hmm.
data, but when we analyzed it, we found non-stationary
Hmm,
from
hmm,
the
hmm.
same sources.
Correct. I understood your constraint. But
Yes.
most of the people are using real data. See, if they want to use the data on Karachi Stock Exchange, assume that Karachi Stock Exchange or Indonesian Stock Exchange, ISX, then we can directly go to the website on those stock exchange and you can download the data. It is easily available. And
Correct.
there are some data. So if you take an IPO, suppose I am interested to know about IPO, initial public offering, and
Okay.
there is a one database called primedatabase.com. Actually, it is running by Pradeep Haldia. There is a one person called Pradeep Haldia, basically from Delhi, and he is having so much of data collections on this field. Likewise, there are so many ready-made repositories are available. But
Yes.
for economics and finance, definitely we want to go through the reliable source. That is very
Correct.
important, because at the time of writing a research paper, we should also acknowledge the source,
Correct.
because the reviewer reviewer may know where the
Yes.
data is from, right? So
Correct.
RBI itself, they are providing a lot of information. Now the people are writing like a how the carbon dioxide is related to stock exchange, right? So
Okay.
many research are going on, sir. For
Okay.
writing an econometric research paper, you can use like weather condition, you can use rainfall, electricity
Yes.
consumption, money value,
Yes.
supply, demand, inflation, not only on
Correct.
related to stock exchange. So many fields are available.
Correct. Correct. Yes, sir. Correct. Correct. Thank you. Thank you for the information, sir. Thank you.
Thank you, sir. Thank you. Any more specific question?
Hello, sir.
Yeah.
Sir, like I have raised a question like ARIMA and ARCH model, sir. So when is that we can do? I might have
ARIMA
ARCH
is,
or GARCH model.
wait, I will tell you. ARIMA is auto-regressive integrative moving average. It is a forecasting model.
Right, sir.
It is a forecasting model. And CARCH and ARCH model is test the volatility on the particular data. Volatility means upward and downward movement. To test whether any volatility is exist in the data or not. For that, we are using arch effect or Karch effect, sir.
Right. So in the research paper, do we need to take it both ARIMA as well as ARCH, or can we directly after stage 3 can we go to ARCH model, sir?
No, not like that, sir.
Yes, sir.
It depends on the objectives of your research paper. Okay, so somebody will go only on volatility, then you can test only volatility is more than sufficient.
Right, sir.
Somebody I want to study, actually there are only 3 objectives behind any econometric research paper, sir.
Yes, sir.
One is to study the relationship.
Fine, sir.
Okay, another one is to study the volatility.
Right, sir.
To study the effect. That's all, sir.
Okay, sir.
If you learn these 3, then more than sufficient. Any tool you can apply.
Fine, sir.
Long run relationship, short run relationship, casualty test, then volatility test.
Right, sir.
This is more sufficient. Then we have like panel data. I have not yet started the panel data or multivariate data. Panel data, so many variables, so many variables in column, in so many variables in row. I have not discussed because we have applied only time series, univariate and bivariate data.
Right, sir. Right, sir. So can we get your contact number, sir, if we have any doubts? We can
Yeah, of course. I'll give you.
Sir, at the same time, if you can let us know your future FDPs or any workshops that you're going to conduct,
Yeah,
that would help us also.
Yes, ma'am. We are going to conduct a lot more workshops. Actually, all the workshops we also posted in the YouTube also, right? You can search it my YouTube channel. Most of the YouTube material I think all the workshop contents we have uploaded in the YouTube also. You can search it. And in time series data, I have not uploaded in my channel. But I will show you. There are some time series analysis websites are available. There are so many websites are available related to econometric model. Definitely, I will share it with you. Right? I will share it with you. You can subscribe the channel and you will get a lot of information related to research. We are regularly conducting lot of workshop related to research, writing research paper, funding, and related to how we can write the thesis, what is the Scopus journal, etc., etc. Right? Yeah. Any more questions, sir? feedback session போட்டுருங்க. போட்டுருங்க.
போட்டதுக்கு அப்புறம் க்ளோஸ் பண்ணிக்கலாமா?
Any feedback? I think we are going to post the feedback link in the Google Meet. You can fill it and give us for 2 to 3 days time. We have a holidays on tomorrow and day after tomorrow. We will send the certificate. We are not directly generate from Google Form link. We will prepare separately certificate and we will send it to you within a week time. And I have posted already I think the data set in the Google Drive, and I also post my material in the Google Drive maybe within another week time, right? Because we have 2 more holidays, we have a lot of other academic engagement with our students. Within a week, we will send all the materials and everything in the Google Drive, and I will send it the link in the WhatsApp group. Okay.
Okay,
Sir,
thank you so much.
sorry to interrupt.
Please,
I mean,
please.
whatever data set that was sent earlier in the Google Drive link, which was posted in the WhatsApp, I haven't got any because I joined only this morning. So if all those things can be posted again in the
Yes, ma'am.
WhatsApp group, that would
Definitely in
help.
the WhatsApp group I will post.
Yeah,
Otherwise, you can send the message to me. I will directly send to you. Don't worry.
Yes, sir. I'll do that. Thank you so much.
This is the feedback link. Please fill it in the form.
Karthi sir, shall
Yes,
we
ma'am.
stop the recording?
Yes, you can stop the record.
Okay, sir. Thank you.
So you can access my profile. You can access